Before we get started, I do want to just talk about, that we are at the confluence of the Bow and the Elbow River here, which has been, like the Wave, a gathering place, except for thousands of years, where people have come together to share stories, exchange ideas, and build relationships. This tradition of collaboration and innovation continues today at the Wave, where we unlock the power of technology to create a better, more inclusive city for all Calgarians. We want to take a moment to acknowledge that we are on the ancestral and traditional territories of the Blackfoot Confederacy, made up of the Siksika, Piikani, Amiskapakani, the Kainai First Nation, also the Ithaca Stoney Nakotas First Nation, comprised of the Chiniki, Bears Paw, and Good Stoney First Nation, as well as the Tsuut'ina First Nation. The City of Calgary is also homeland to the Métis and the Optimusquak Métis Government District 5 and 6. We acknowledge all Indigenous people living here and who have lived here on Treaty 7 land. At the Wave, we are dedicated to creating an environment where new ideas can flourish, where the spirit of cooperation and creativity drives our collective progress, inspired by the enduring legacy of this land's first peoples.
Okay, thank you very much. Thank you very much for the introduction, and we are very excited to have this collaboration with the City of Calgary. Thank you very much for Jason, Monique, and all the Smart Cities team that has been very much working with us for the last few years. And in developing a lot of projects and experimentation and testing a lot of new ideas. So the RoboCraft project I'm going to talk about innovations on learning and program, is a collaboration between the Laboratory for Integrated Design at SAPOL, at the School of Architecture, Planning and Landscape of the University of Calgary, and the city. And how did this project kind of come about, or what is what we are trying to do through RoboCraft? So for the last 15 years, my lab, we have been trying to research how can we use shape, geometry, the way that we make things to make shapes that are more efficient and more sustainable for the built environment. So shape that use less material is closer to the source, and that can be better built. And we have also been working a lot with robotics, with robot arms, to help us fabricate and deliver a lot of these forms. And we believe that could be the solution for a built environment that changes, that adapts, and that do not has to be demolished, or is not abandoned, or is not empty. So if we can create buildings and spaces that are interactive, where people want to live and are more efficient. And what am I on? And something very interesting is that on the car industry, from the 1900s to now, you can see a big difference on how cars were made and how they looked, and how cars are made now and how they look. It's beyond tech. It's not only that we have a smart drive and the GPS and all of these sensors that are a bit horrible of reverse and this and that, but it also looks different. It's also different. So we really are trying to go beyond just adding a layer of technology, but trying to go into how things are made, built, and designed. In the built environment, it's not the same. Buildings look pretty much the same, if not worse, than 100 years ago. So why is that happening? Why our buildings are not like our cars that look so much different right now? And that's where a lot of our work kind of really comes from and started to take shape. And this is something I find really interesting. Like the patent to do reinforcement bars is from the 1866 or 1900s. And when we built all the towers around the city, when we build concrete, we still do this kind of reinforcement bar. 124 years, we still use exactly the same tech. And if you tell me, hey, Alicia, well, in Calgary, we don't use so much steel like in other countries, the patent for CLT, for cross-laminated timber, is from 1923, 101 years old, when the first CLT lamination was done. How can we keep building with the same technology and not question it and just think that we're going to achieve efficiency and sustainability through like adding tech or adding kind of more sensors? And that's where kind of our research kind of really tries to focus on. Of course, we use AI, and we love AI as everyone else. We know that AI can give us a lot of great ideas The only problem is that we still have to build them. So how do we build all of the new ideas that that AI can give us? And that is for us where this RoboCraft project comes, and we are trying to use and work here in the wave. We are going to have a big robot coming on where his little brother is there right now, but he will be bigger. And we are kind of looking at how can we use advanced manufacturing to design and fabricate. We're going to focus on urban elements that are near site, so we're going to fabricate them here. As a prototype, of course, eventually we aim the robots to be moving around, are customizable, so they are different, not generic, not mass-produced, not all of them the same, are participatory, so citizens, the people that live, that will use them, has an opinion and can design them, and also affordable. What we aim to reduce with this is the timelines, the environmental impact on fabrication, but also transportation cost, carbon footprint of bringing stuff around, test novel fabrication methods, and of course, working on upskilling and training, which is kind of one of the main goals of this RoboCraft project that we're going to be developing here. Why robots? Because robots are flexible machines. So one single machine, the arms that you see there, they're bigger bodies. The one that we are getting will be like this one, but white, not orange. They said no orange here. So it's that guy. And so they can do like pick and place, for example. They can help us assembly stuff. They can help us 3D print, something that we're going to be doing a lot here, 3D printing. They can also do milling operations. That's a lot of the work that we do, research that we do at the lab, and also my own research is a lot of digital timber. And also they can do band sawing or any other thing, circular saw. They wouldn't allow me to do that here, but we could do it if we want. So anything that you can hold at the end of your arm, the robot can hold at the end of his arm or her arm, depends. And the robot can also do it, right? So that's where we are. What I'm so fascinated with robot arms, and we have been working for like 10 years or more than 10 years on them. And this is a hot wire cutting, for example, again. And the interesting thing is that when we talk about how are we going to do these new shapes, are we going to be making up stuff and getting more expensive and crazy stuff? No. Actually, a lot of this is learning from the past, from stone structures, from brick, from structures that maybe were more efficient, that maybe were more sustainable, that were using materials closer to the source. So a lot of the learning from the past that we don't do anymore, we can start doing it again with mass customized robotic processes. So for example, this is the same stone cutting, this is hot wire cutting with robot arm. Each stone is different, each piece is different, right? So we are trying to go to learn from the past, those efficiencies, see how we can innovate and how we can bring them back to robotics. This is the guy that is there. Right now he's drawing, but he also does hot wire cutting. So he's kind of trying to test a lot of these ideas, even at the smallest scale, and that could also happen at the big scale. So whatever the small robot does, the big robot will do. So we are comfortable in testing our ideas at different scales, and we don't have to test at everything on a bigger guy, right? So this is Nachito, that you can see him down there, and kind of hot wire cutting. And these are some projects that we did, for example, with hot wire cutting, foam, trying to see how can we reinvent how we live. However, it's not only about reinventing these shells and say, well, this is a shell 5 centimeters thick, concrete, has been standing for 12 years. We built it in 2012. So, like, trying to learn from the past, from fabrication methods that were more efficient and more sustainable, but not only. We don't want to innovate on everything. This is a project that we did in 2018. Knit Candela, another shell with a fabric formwork, and also like very, very thin, 5 centimeters thick, all concrete, lots of people there. But also, how can we mix these with traditional ways? We don't have to innovate in everything, but how can we make critical innovation to change how we live only where we need it? So can we mix these with traditional methods? Can we mix these and actually give people a better city that is more beautiful, more elegant, more efficient, while still keeping a lot of the traditions of how we build? So we are looking at this intersection. It's not everything is new, but the intersection between the new and the past. So The engagement with the city is about advanced technological development in materials, in machines, and in intelligence. Those are the kind of the three aspects that we are tackling through the RoboCraft project. And I'm going to show you some examples of work that we are doing currently with some with the city past projects that on these different areas. So how do we talk about engagement? What do we mean by intelligence and engagement? This is, for example, a facade that we are developing for one of the buildings in the downtown. And here the idea is that citizens can come, or users, and make selections of how they want it to work, but we are giving them feedback so that when you pick something, you know the environmental footprint, the amount of material, the amount of fabrication time that it will take. It's not like if you go to IKEA and have your configurator to do a kitchen and you don't know where it is coming from or where it is doing. So can we make furniture and design as food that you see the ingredient content and you know where it is sort of know how many calories you have, how many carbs, you can know how much material it is, how long it took to do. So we want to really be very transparent with this information. So the researchers in my lab, some of them you will meet here also, are working in this kind of participatory platforms where people can come, select, and all the analysis are doing at the back end. So as people are doing selections and are picking, we are kind of analyzing all of those to tell them, well, that will be more efficient for energy performance, for thermal performance, for material fabrication, for robotic fabrication, for amount of material that you require. So as much information as possible giving back. And everything is, of course, calculated. So we are working in a lot of these platforms. It's something we are aiming to do also with the robot, with the, part of the RoboCraft project, to have these where people can interact. They won't know, but they will think that they are designing, but we can give them as much information as possible. Be very transparent. Every decision you make, how much it will impact everything in the supply chain. So this is the timber bending, for example, for that facade project. And then again, robots bending. So in this case, we the user is selecting, is moving back and forth, is picking something, and then the robots are bending it. And then after the robots bend that curves, after being analyzed, they mill, they cut. This is one of the prototypes that we built for this project. Like everything designed by humans with our input, giving them feedback. So that's something that we want to achieve through this project. Other thing, and that's the bench that you see there, one of them. Other is like in this case, we were working again with the Downtown Association, with Jason also. Like, we want to do benches, but they are very big, very volumetric. How can we carry them? Can we make them out of flat sheet material? So then you only bring flat material, you bend, you fold it on site, and you get strong results. It's a lot easier to ship sheets than to ship benches, right? So we kind of work on that. We did the structural analysis, and then we did these benches out of like aluminum, thin sheet aluminum, 3 millimeter thick. But by the curvature, by the shape, by the form that they have, they are really resistant. And they have been used a lot of times in different events, Chinook, Blast, and the Korean Festival. And it's super exciting every time I see them somewhere because they are still there and very, very resistant, right? With very, very thin material. So really trying to use as minimum amount of material to create things that are close to the source and not having to transport them. And I think these were when they were new, first time we deployed them. So very exciting collaboration. So this is something that we are definitely going to keep looking at, right? Fabricating, smart use of materials and close to source fabricating. How can we deploy more of these techniques that don't require to transport big volumetric stuff and can allow for thin material to perform very strongly? Also, this is another thing we did. We took the robots. One you will see Freddy. He's right now there doing some face tracking. But here he was drawing. So also, how can we bring this outside of just these doors or this building and bring them closer to people? This is an engagement event that we did in 2022 also with the Downtown Association, facility with Jason also. And like kind of bringing the robots to people and allowing them to engage and to have a say on that. Very exciting that we had like tons of people participating. We had queues. And in this case, the robot was just like, was just drawing. So people was like, one robot was taking a photo, other robot was drawing. And it was so exciting to see the enthusiasm in the city for the tech, right? Like at some point we had a line of like 30 people outside and the researchers were there. And some people, we told them come back in the afternoon because we were just delayed drawing so many robots, so many PFAs. People will come back. Even next day, people will come back to pick up their drawings made by robot. So seeing the level that the city has of enthusiasm is really inspiring and has really motivated us to keep this collaboration going and to work harder to make it happen, because it's really, really, really fascinating. So this was, these robots were like for 3 weekends drawing, and he's now there. And then another project that we did last year, also with Living Labs with Anne, was like using topology optimization. For example, this is a shell that we built in 2013, and you see that it's full of holes. So the holes are not because we like them. I mean, we do like them. I love them. But also it's because that's where there is no stress, right? So that is where the structure was not performing. So we remove that material, we make it look very beautiful, but also we use like 70% less concrete than if it was all full. So we kind of look at this, and the question here was, can we do the same if we reduce all the material, but can we actually make something, make the concrete do something else? So we developed this bench, we remove all of this, all of the filling using topology optimization, and we put a sand battery inside to kind of heat it, to kind of think things that heat, can it capture electricity, can it heat? So these are some of the initial tests at the lab on the first little prototype that we had. And then this is the full prototype. Again, everything hot wire cut with the robot arms, and then casted. And then inside this bench, there was a battery, there were sensors. It was at the Glenmore for like 6 months, I think. Now it's removed, and kind of hitting when people kind of arrives. So kind of really trying to see how can we engage on this through using different algorithms. So really like kind of the idea of leverage technology to create sophisticated, dynamic, and customizable processes. And that's where kind of our project lies and what we want to bring to the Wave and to this project. And we're going to be working a lot with 3D printing, so the big robot will be doing a lot of 3D printing, concrete, plastic. We are looking at different mixes for urban elements. This is like just a clay extruder, so we're going to go a bit more sophisticated than this, but try a lot of 3D printing. And the idea is to have, flexible and adaptable technology on materials and machines. Near site, so low carbon footprint on transport, no carbon footprint on processing. We're going to try to like also engage, we're engaging with a lot of like local companies. Customizable design and fabrication, where the users, the people from like city people, designers, support, everyone can actually have a say on the design. It's not top down, but it's bottom up. And then upskilling and training, and really trying to use technology for social innovation, for new ways of building and new ways of looking at the built environment. And I think that these are the main goals of the RoboCraft project that will be installed here for a few years. Thank you. Oops. Oh.
Any questions? Yes.
I want to know, through what methodology do you employ to determine how much, when you are applying a curvature to, as you mentioned, a sheet of material?
Yeah.
How much, what's the methodology to determine how much curvature you can apply to that material before it's stressed to the point of breaking? And then also, when you design material, what other considerations or the methodology behind environmental factors like temperature, swing temperature, and also UV?
So we simulate that. So we have tools to simulate environmental performance, thermal performance. For the curvature, we also simulate that, and we also test physical. So we do a lot of physical digital comparison, like with the aluminum benches. Sorry.
And just, I can't think of that. I'll let Alicia catch her breath. But so with this project, we talked about the different kinds of things we can do, right? We'll print in concrete, and we've got another project where we're the UC with Alicia and the U of A and Zaha Hadid Architecture are printing in metal. And so as much as the 3D printing is less of this science experiment, it's also a test of our policies and our processes, right? Like the 3D metal project, to get it through to development permit, we're actually using it as a as a playground equipment because that's where it had to fit in. So we get a chance while the students are doing two things. They're gaining a real world project, and they're helping be part of city building. But we're getting to understand where our policies aren't ready for what's next, right? And so it gives us a chance. Okay, so this is our first 3D metal pavilion. We're going to have more of them. How do we get our permitting processes ready for that? And I'll let you.
Yeah, fine. No, sorry. Yeah, sorry about the curvature. So we have been working with curvature for a very long time because we know that curves are more efficient, and we know that in nature there are no straight lines. So that's where we really kind of know that they will always be stronger, that the strength through curvature is given, like any shape will deform into an arch, into a catenary. Intention when you flip it is in compression. So, but with the aluminum benches, for example, we did a lot of testing, a lot of bending, and then we start to capture that information digitally to know how to calibrate our digital with our physical simulation, especially when we talk about concrete printing or steel. There is a lot of humidity, a lot of factors that affect how the material will perform, right? So we do a lot of calibration and then a lot of simulation. So a lot of the work we do is simulation. Especially for all the curvatures, but we know that curve is better. Yeah. Sorry for the cough attack.
Maybe we could talk about again we talked about the students' resumes, their experiences is all portable, right? That especially when we did that bench, there was a big fear we were losing young people. And through that project, right, yes, their resumes, experiences are portable, but their professional network isn't. And those students met with Calgary Downtown Association, Arts and Culture, myself,
Correct.
right? So they build their professional network here. They get to be a part of city building, which gives them a little bit of pride. What benefit do your students get out of working with the groups in the city?
Well, yeah, I think that they get to know more about the whole process, right? Because sometimes, like in the architecture school, maybe they think that that because they are designing something, they are going to change the world, right? But then they kind of don't get exposed to there is planning, there is a structure, there is all of these other things. There is people engagement that you need to consider, and when they engage with the city, they kind of go through some of the bureaucracy, but they also kind of get engaged with the whole process, right? And they also get their designs being used or their products being used. So it's a full design to full scale fabrication cycle, which I think is super valuable because they go beyond a model. They go for the real thing. Yeah.
We're here and then we'll go to yeah. Okay.
What are you most excited about with the future of all of this?
I'm excited about a more beautiful and sustainable built environment where people really can participate. And I think that I do find it conflicting that our buildings look worse than before. And I think that we have all the power to make that change.
We'll go stand because I saw your hand up and then we'll go back to the back. I'll get you.
Sorry.
Senator, you have another question?
There's a question.
Yeah, I'll get, yeah. Okay, sure, Chris.
Yeah. You talked about efficiency and sustainability. What if you could speak about scalability? And what are the considerations for scaling something like this?
With timber or with 3D printing, we do everything in pieces, right? So, for example, with the facade project, the size of the element comes from the robot, from the size of timber, and from the connections and the joinery between them. So that's a very important thing. The scale, it's depending by the machine, and that's something that I think is really a paradigm change on the way we build, because right now, the way that we build, the dimensions are coming from the vehicles that move material, right? Whatever cannot be transported in a lorry cannot be taken on site. So something that we're trying to see is how can we change the dimensions of with the concrete printing of bricks, of what is a brick when you have a robot building, right? It's very different than a brick when you have a hand or bricks are made on the human hand, right? When you change, the size is not anymore a human, but it's a machine. How does that change? When transport doesn't matter, because we can, like on the box, we can bring the robots near site, be fabricating there. So then it doesn't really matter if it fits in a lorry or not when it's finalized. So a lot of those things, I think, is the work that we are doing. And for scaling, for example, this piece here is part of a large facade that we did last year for the Venice Biennale in Venice, and it's a full facade, so it's made out of components. However, the dimension of how we got the size of this component is based on the size of the robot that was going to fabricate it, and the size of and this is a CLT. Laminate is a CLT that we did in house, tested and also milled. So it all depends on the machine size. But definitely panelizing for concrete printing. The other thing about shells or about curvature is that if every block comes together, you will get efficiency, right? You don't need reinforcement, so it will stand. Yeah.
With our fleet fabric shop, so we have a fabrication team that basically done lots of vehicles in terms of fabrication designs and colors. So it would be cool to have you guys show.
That would be really nice.
I don't know if they need to review, but I do see that's an opportunity.
And that's kind of one of the pieces of this experiment is that we used to have the carpentry shop, right? And then things became very IKEA and very modular, and that ramped down. And now we're getting to the point where design is democratized and customization and in-house build is possible with 3D printing. Actually, one of the great things about having Alicia's PhD students here for the next several years. So Maddie was able to design actually the grippers for the TV on Freddy were all printed in our 3D print with our 3D printers, right? So we're getting these custom adaptations or on the fly, really quick tools and machined parts are really easy to develop. And so maybe, right? Maybe again, the science in the 3D printing is out there. That's not the innovation. It's the experiment for us is seeing whether it's ready for city to start using. We talk about upskilling. What are those skills that we need in-house to do more of this, right? How do we become Maddie and be able to print the custom builds that we need? And then, so the skills and the policy and the durability. I think the other piece we talked about is when a car hits a concrete bench or that pavilion, right? That we can crush it and reprint with that same material. So the carbon footprint of concrete is huge, but if we can reuse it, right? Or if we can melt down the plastic from our other 3D printers and turn that into more filament to print again, that's all things that we can do with the university.
Yeah, and I think that, something we have been also working for a few years now, this is on the shop, on a robot shop, is the whole idea of upskilling, right? Of training, of like, kind of making these robots being more out there and being part of normal fabrication processes. So that's something that we have a shop, and then we have really been kind of developing that part into how can we bring pride back to the construction industry. And I think that is something very fundamental because the construction industry, or like all of the building industries, are kind of lacking pride. Since I was a child, I was always in construction sites, and it was always exciting, fascinating, right, for me to be there and seeing everything going on. And right now you see that people are not really excited to be there anymore. And we have been to bring in some digital layer at it, trying to make it more attractive again for young talent. And I think that that's something that we really want to develop and to explore.
Sandra, one more? Sure.
Okay. You made reference to ancient structures, and some of them they were quite novel for their time and very advanced mathematically. Do you know if those mathematics of the ancient structures have been captured and put into data sets that we can now use today to advance current structures?
Correctly, yes, absolutely. So like the shell that we did, the Knit Candela, for example, that was a collaboration I did. I work with Sahadit and the Block Research Group in Zurich. We work very closely with them, and they have all of the, for example, 3D graphic statics, ways of calculating shells and bridges from like the 1800s, 1700s. They have captured that and now like make digital tools for that. So a lot of that is coming from like that kind of knowledge. So we do have a lot of and a lot of the like, it's like a stone construction, for example, it disappeared because no one was able to do it anymore, right? But now we can calculate, like we have tools to calculate all of that and to do it with the robot. So definitely the knowledge of all the structures is amazing, and the vernacular construction, and where like there were very little waste. There was no waste at all, right? So that's something that we have been working on like for at least like 20 years now. Like in really kind of like the shells that we have been building, all of them are looking at Felix Candela, at builders from the past that knew how to do efficient. A big problem, and to Jason's point, a big problem of a lot of those structures from the past is that none of them will pass code today. So I think that's what we're also very excited to work here with the city, because unfortunately, like a lot of the code is not flexible or catching on, right? It's very top down. And when you think about, well, if you don't need so much concrete, you don't need so much like material or so much structural, why? Like cathedrals from the past are here today, thousands of years after, and our buildings keep being demolished. So I think that there is a big layer of risk that has to be taken in code and into saying, well, you know, I can calculate them, we can build them, we can build a bunch of them. Can we take the risk of having something that is like maybe not structurally as you will expect, but we can guarantee it will work? And a lot of these structures, what we do is we put like, sometimes for them to get them to code, we put like bags of sand, we load them, so engineers will see that they don't collapse, and then they will believe that we can build them, right? So I think that there is a big, that is not about calculating building and design, it's also about that risk, about like, and it's a very calculated risk, I will say, because we know that from the past, they have been there for a long time already. So I think that that's something we have been discussing with Jason a lot, and one of the exciting points of being here at the Wave is to kind of how can we test this and start to poke into that. Yeah.
Yes.
Hi, my name is Sarah. So I'm also a social innovation student at Mount University, and I'm taking the course like Civic Innovation, and we've done like a lot of observations on the city. And like our biggest thing, and like talking with other students as well, was that like architecture seems like quite bland. And anyways, I just wanted to say it's really cool that you work with like Zaha Hadid. That's like sort of something that like we see as like international, not something that would be in like Calgary or something. So I feel like there is interest in like students, but like what type of students would you be looking forward to like work with?
Excited students. I think that that's the more important thing. Students that are enthusiastic and excited, I love to work with them. Students that just want to like not take any risk and just want to be doing traditional stuff are the most difficult ones. I don't think it's about the skills, it's about believing on it. And we have a Zaha Hadid pavilion coming soon to be unveiled, right? It's in the making. We're aiming to fabricate parts of here with the big robot. So it will be coming soon. I'm very excited for that collaboration in the City of Calgary. We are working with them on the finalizing the project. But yes, I mean, I think that something also to your point about robotics and about the techniques is that ornamentation was very expensive at some point, right? In the past it wasn't, and now all the buildings maybe are bland because ornamentation, decoration is expensive. With digital fabrication, with the robotics, the 3D printing, ornamentation is cheap. There's no cost to it. And a lot of the times, like the pod I showed, the ornamentation was just from the gripper taking them, and people were like, oh, that's so beautiful. And that's just the machine the machine showing its own personality in a way, or its own thing. So how can we express that? And I think that it could be that we can get very much efficient ornamentation by engaging with machines, and not just efficiency through making more of the same.
Okay, thank you. You know,
Thank you.
Alicia is one of my favorite Calgarians, and she should be one of yours as well. So she's being very humble. So on top of working at the School of Architecture and Planning, and being a very recent top 40 under 40, right? Top 40 and 40 does a ton of work with Zaha, is bringing Zaha Hadid here for some conferences next month, but we'll have our first Zaha design in the city here, and it does some amazing work in Roatan, working, upskilling the locals with how to do 3D printing so that they can print housing first and then high-end housing at the end.
High-end housing, yeah.
With 3D printing. And there was one more thing I want to, oh, and you just came back from teaching at Penn State as well, which is the
University of Pennsylvania.
University of Pennsylvania, which is like the premier design school in North America. So we're so lucky to have you here in Calgary, but also here in the WAVE. And then you talked about risk taking. And so that bench, we have one of those red benches over there. And again, we're a very small budget that was going to be going to leasing benches. We're able to take that and turn it into an amazing project that has lasted now 4 years almost.
Yeah.
But the risk taking was, you had all those pictures of students jumping on them and tons of students on them. We still had to pay an engineer, even though it was designed by one of the predominant architectural student, professor and designer in the country. We still had to have an engineer review it for about $7,000. I think it cost us.
And we had to send them the mesh because they didn't know how to calculate the curvature.
Yeah,
right?
exactly.
So we had to send them our calculations. So it was funny. Yeah.
So that's just again an amazing example of where code has to catch up. But I want to thank you so much for coming here, and we can't wait to bring you back and share more stories.
Well, thank you so much, and I'm very, very excited to collaborate, and very inspiring to see the enthusiasm on the city. We are very, very excited. We have a few surprises coming, the pavilion, the conference next month. We're getting Zaha Hadid Fosters, so we're getting people from very high-profile offices are going to come to talk at the Banff Center. So everyone is invited to come. It's called Acadia, if you're interested. Yeah.
All right.
Thank you.
Thank you so much, Alicia, and we'll chat soon. I'll take this.
done in primary that essentially dies on the vine, and a lot of work gets done in the practical sense that is like, oh, well, this is how we're going to mass produce. But you really need that flow of ideas and information and innovation through the system. And we always refer to it as an ecosystem for that reason, because I think it's important. And I just wanted to add that as a bit of a note. I'm just going to give a very, very brief overview. So I guess I'll also set you guys up for doing the right thing or performing how we hope. We're going to do three presentations. Keep them short, keep them brief, who we are, what we do, some of the collaboration work, and then get into a discussion with you guys, hopefully. And we've planted my colleague Pia here with some questions, but preferentially they would come from you, and we'll talk about how this is going to work. So the Applied Research and Innovation Services at SAIT has basically 5 general areas. It's Green Building Technologies Access, that's myself. The Center for Energy Research and Unconventional Technology, that is largely renewable energy systems, et cetera. Center for Innovation Research and Unmanned Systems, that's drones, that's what Wade will be speaking to specifically. And an Innovation and Research in Applied Manufacturing and Materials. And that is really the group that tackles the complex question of what is it and how does it behave. And one of the things we are really emphasizing in state strategic plan and our own work is how do you bring all 4 of those together? And in order to help bring that all together, we have an independent research group which does a lot of the kind of overview, oversight, and collaboration systems. So we are living the life that we hoped, which is trying to build that more comprehensive system to really tackle complicated problems. Getting into GBTAC specifically, so our mission is pretty simple. We want to lead industry in building greener buildings, full stop. That means you do commercialization, that means you do research, that means you do monitoring, that means you do a soup to nuts, as they would say in the business system for how to build better buildings. We do have a research center that includes offices, and probably more important to our collaborations with WaveTech, we have our own testing facilities. So we do everything from structural testing to thermal testing. We'll talk a little bit about those services, but clearly we have the ability to not only build things, but fast prototype, investigate, and test other people's ideas. And I think that's, again, when we talk about that comprehensive research ecosystem, that's what we're talking about, is the conceptualization from idea to testing to prototype to commercialization and execution and scalability. We have several research themes, and I'm going to add an overlay at the end of this, but the first one is our building science. If you are talking about how to keep water out, heat in, all of the things that make a building, what glass looks like, how does it behave, how does the structural systems work, that is in the general area of building science and the building envelope. That includes retrofits, that includes new construction, that includes testing, of course. The second one is specifically related to energy, and that is energy use in buildings in this context. But again, we always hear the buzzwords of net zero energy. Again, I say this as a former architect. I love that term because any building's net zero ready. But tell me how you measured it, tell me how we're going to quantify it, tell me what that means in execution and design. Because that's where it becomes an interesting problem, in my opinion. And I think that's really where it gets fascinating. And that includes all of a sudden, if you're going to tell me something is net zero, well, how do I monitor it and measure it to make sure it actually did become net zero? All part of the work we do at GBTAC. And the last one is, and this one relates a bit more to the work that Pablo does, so that's the kind of loop that brings us all together. We call it architectural ecology, which is essentially all the things that deal with site use, water maintenance, water servicing, water quality, water reuse, all of those things. But the ecological nature of the building, for biophilic design, all of those wonderful phrases, and a very interesting area of research right now, because I think the idea of building a building like we did in 1976 has finally left the building, and it's good to see it. Like Elvis, it's good to have a go. One of the other kind of tangential things that we do because of the research we perform at GBTAC is we do a lot of education industry training. And I think that's a big part of, again, we've kind of put this together to highlight how we have in the past and will continue to work with the city. And I think that is where we're headed next. And I did this in a really simplistic form for a reason, because I'm much more interested in talking to you guys about what this means. But I think we have at least 3 areas that we have commonly collaborated with the city, and that's training for staff and industry. We are excellent trainers. We're an educational institution. I would be ashamed to say we don't train well. We do. We train very well. But we can also talk about how to do this on a different way, which means not only taking industry and saying train them in X, Y, and Z, but getting them to think in a different way and opening up the ability for them to explore their own ideas in a constructive, practical, research-oriented way. Case studies and student integration. Again, one of the things that really attracted myself to the Wave Tech Center is the idea of using students as a kind of a fast prototyping service. And I'm going to deviate off the script for just one moment because I think it's important. But the idea of being able to use student work and student projects as being a research service, a prototyping service, and a data service is incredibly important. I cut my teeth, it's been a long time ago, but I still work closely with a lot of colleagues in consulting. Consultants are wonderful at providing you the solution they know, because that's what they do well. That is why they get paid well. They provide the solution they know fast, effectively, and on time. However, if you are interested in innovation, you start needing a little bit more of a sophisticated methodology that involves things like an escalation of ideas. So for instance, one of the things that we've kicked around just kind of in loose format, using things like student capstone projects to say, here's a problem at the city. Give us 9 ways to solve it. And we can evaluate those 9 ways and say, okay, from the 9, these 3 are worth exploring in greater depth. These 2 are worth actually doing a prototype on. This one's worth sending to an engineering firm or an architect to say, let's get it built. And that ability to take an idea from broad conceptualization is I have a problem to here's a series of solutions you can employ to here's the solution we've decided on for all the right reasons. That's a really powerful tool. And I can't emphasize enough how that what we're doing here today is the start of how you essentially do idea exploration. And that's really powerful to me. And so I can all read, I don't know, you think of it what you will, but we've worked with the city a lot in the past and we'll continue to do that. I think this just gives us a new and interesting way to further that relationship. One of the last things I just want to cover before I hand off is, I think it's very important to talk about, whoa, I've hit a button that's gone crazy, sorry. But the idea, yeah, fair enough, man. That's right. Damn you, Freddie. What I was going to say, though, is also the ability to foster partnerships. So again, being a major educational institution, partnering with the U of C, partnering with Innovation Alberta, partnering with industry, partnering with the city, let's identify the common problems, prioritize them in a way that makes sense to what benefits the people and the public and everybody, and use the right partners to get the right solution sets explored in a comprehensive fashion. That's kind of what gets me out of bed in the morning, and I hope that's what gets everybody else out of bed in the morning too. With that, I've probably talked way too long, and I'm gonna hand over to my friend Pablo.
Thank you, Justin. And yeah, I'm just gonna go as processed and quick and efficient as I can. I think I just want to add, as my colleagues mentioned, the focus or the core of the scope of what I do is talent development. From the point of view of the students, the critical mass or the meat, the excitement piece on my end is the students. I directly steward 3 core programs under my portfolio. Water, integrated water management, environmental technologies, and chemical laboratory technology. So I kind of summarized the core areas of expertise in my team around those 3 areas, all wrapped around environmental sustainability or sustainability at large. I know sustainability could mean many different things. I usually frame it as sustainability, aero, environmental sustainability, aero, well, 3, right? Water, environment, and chemistry. All right. Okay, so I'm just gonna follow exactly the template that Justin used. Very quick, as I said, the stewardship of 3 core programs. We collaborate. I love the concept of sustainability. I always say, well, what can we use in terms of opportunistic concepts so that we can bring umbrella values to many different stakeholders and kind of have this relatedness very quick. Everybody can understand what do you mean by sustainability? Well, sense of place. preservation, beauty, values, right? We have, because of that, we have constantly partnership both regionally and internationally. And as I said before, like 75% of my portfolio is about managing the team. What do you mean by that? Well, think about faculty, think about students, think about techs, think about facilities around that. And we want to leverage all these facilities as well. But 35% is very broad and open-ended. It means research and innovation. And that's fascinating to me because it allows me to, how can I use these components of education in terms of students and programming that we can feed through that 35% of innovation and research to further advance the mandate of what we have. So I put in some slides that probably Wade will find familiar around drones. Okay, so similar, we have it's a big family. Believe it or not, in the School of Energy, it's the smallest pod of portfolio. I am fascinated, I'm blessed with great caliber of expertise in many different areas of expertise. But if I can summarize very quickly for you what kind of facilities, similar to what Justin said, we have probably one of the best water treatment lab facilities in the province. We have a whole, and I love one of the sheets around digital divide because that's something that we as a team believe very at the core. We have a virtual reality facility that's basically tackling digital literacy. And for the chemistry, that's probably our most comprehensive suite of facilities, analytical instrumentation, benchtop, a lot of different areas, and field. Because as you can say, for water and environment, probably 60% of everything that we do is outside. So Internet of Things, air, soil, water, groundwater, surface, anything that you want, we have to have that, not only as part of our mandate for research, but also competency development. So we do have a lot of field schools. Our students spend a lot of time outdoors learning how do you measure that, not only to hug the trees. I'm just gonna use this. What?
It's telling you to slow down.
I think it's, oh, wait. No. Right. Okay, very quick. All right.
It's going to take a sec. We're just moving in. We're a little bit beta, and our internet is a lot of duct tape right now.
Oh, right. I see the screen changing here, but not in the. Okay. I could just read these in here, and everybody can imagine.
Yeah.
That's right.
Let me paint a picture. Yeah. On the video feed, it'll look great.
Oh, it will look great?
It'll be on. It's on page, but just the stream shares is.
Okay, well, I can. If I look at the slides, I can just tell everybody because everything is summarized in here. So the themes, as I said before, the themes. One of the core themes that we have is water management. So you can see, well, we cannot necessarily see that, but as I mentioned before, we have from the water treatment side, water and wastewater treatment, collection and distribution. We have great partnerships with the city from many levels, not only in terms of research and capstone projects, but also practicum. So we constantly work and collaborate with your colleagues. We also have, as I said, we have the water treatment side. We also have the water monitoring and sampling as well. So we have equipment and training around that area. From the environment, right now, we just hosted actually one of the, in partnership with the city actually, a theme around food systems, in particular urban farming. So core of my team is very interested in food systems, so we are really exploring that area. As I said before, similar to water, anything that you can think of from the environmental sampling, monitoring, and analysis, from the field to the lab analysis and testing we have, and something that is relatively new, but it's a huge intersection for across these different disciplines is the digital space. Think about I love that there was a lot of mentions around 3D printing, 3D modeling. I love that, and one of the reasons is because that's an integral part, and Wade probably has that. Well, I know he has a huge piece of that from the drones point of view, not only from the analysis, but communication and engagement. As before I started working at SID, I realized that drones were a disruptive entity, not only because of, obviously it's such a cool tech, but because I realized that it was an incredible way to engage with the public with complex or complicated information, and that's the 3D space. So we have our lab of virtual reality has a suite for 3D modeling, and one of the projects that we had was to create an asset of 3D models for the library. I don't know if you guys are familiar in that world, but if you just look at Sketchfab, you just Google Sketchfab, you're gonna realize that all over the world, there's a whole community that it's all about 3D communicating. And you can find a bunch of assets from the City of Calgary there. Just Google Sketchfab 3D, well, no, Sketchfab City of Calgary, or Sketchfab Calgary, and you're gonna find a bunch of people that are geeks, or they're just digital enthusiasts, and they're just uploading their models. So when we pitch to the library, hey, we wanna have a landing page for SID where we can start placing that, because we wanna make sure everybody understands that it's so easy now to use 3D modeling as a way to, or as a proxy for the 2D world, because most of the times, when I realized that we had to mainstream that, is because one of my colleagues was showing me that for their assignment, they had like 10 pictures for a turbine or a valve. Like, rather than having 10 pictures, wouldn't it be easier just to have a 3D PDF and just have the students rotate and do whatever they want and really look at it in a good and fine detail? And people were like, well, I mean, how do you do that? And I think for me, it's going to the point of the digital divide. I mean, if you're not necessarily interested as fun, if you're a gamer or you like a little bit of tech, you're gonna think that those items are incredibly complex, or they're only if you have a very high proprietary technology. But everybody that now has a phone like this with 3 lenses can do things that 10 years, 5 years ago was like really unthinkable. Like you need a special type of software, but not anymore. As I said, just search for Sketchfab. Are you gonna realize that the 3D world is here in terms of the democratization or like the accessibility. So one of the things that my team has at the core is that's why, or hence the idea for a digital lab or a virtual reality lab is to mainstream that portion from the point of view of environmental sustainability, but everybody should have that piece as well. So there are 2 core pieces that we want to have: the digital literacy in the form of accessibility, and the second one is the open access and open source revolution. So the reason why we push so much in that area is because, as much as, of course, there is the reason for the copyright and accessing properly curated software or licensing for tools, there's a whole world like Wikipedia where you can have the beta for peer-to-peer of information like programming, like GitHub. So we want to make sure that our students, as part of the digital divide and digital literacy, they understand that there's a lot of really different, interesting, and very well peer-reviewed tools around the world that should be of use to for everyone. It just requires you. For me, in my case, for instance, it was just a fluke that I ran into something called R that is very well used now for data analytics. And it's almost like Python is the standard for data analysis. And it's an open source tool. And back in the day when I started using that, it was more anecdotal that I ran into it because I needed a tool, and every lab that I was going to use the different software that you had to pay for. So I found R. And I really realized now it's a very mainstream tool. So again, going back to the point of why we push for this digital lab, like a virtual reality in my group, from the point of view of environmental sustainability, is really trying to tackle the digital divide. And I don't know, Wade, do you think you can use the...
Just to be honest, like I said, it's the screen, it's not your computer. It's streaming here, it's streaming online, just not...
That's okay.
It looks like we dropped the internet at 9:30 and it hasn't rebooted yet. So I'll work on it after. Sorry.
That's okay.
All right, do you want me to take over?
Yeah, take over.
Okay. All right, so thanks.
My focus is on the Drone Center. So I already talked about the center name. We have two focus areas: applied research. So we're focusing on working with clients to solve their problems, and that could be small, medium-sized companies all the way up to the big players, nonprofit, government agencies, whoever has a problem and comes to us. We are in a position to work with them, which is great. We also do quite a bit of work internationally as well, with partnerships in Germany, Switzerland, and several other countries. We also have a remotely piloted aviation training center. So again, as my colleagues mentioned, a lot of focus on student learning. So we do offer training in a larger platform, so platforms that are greater than 25 kilograms. So these are drones that are operating for 3 hours with up to 150-pound payload, running jet fuel. So they're not just your small drones you'll see at Best Buy. They're quite a bit more, much more rigor. There's a lot more maintenance requirements, so requires an additional training feel to it. And then SAIT is also well positioned in the aerospace industry in general. We have a School of Transportation, and within the School of Transportation, we have a 15-week RPAS, or in Canada we use the term remotely piloted aircraft systems, or RPAS. Other countries utilize unmanned systems or unmanned aerial systems, but in Canada we use the RPAS acronym. And we have that remotely piloted aviation training center. We also have the 15-week certificate program, and we also have an aircraft maintenance engineering technology program. So lots of different positioning in the aerospace industry. We also have under the School of Construction, we have a lab that's called the Connector Space, and that's really focused on capstone students. So bringing together capstone students to enable the adoption of technology. So drones, survey equipment, anything that the students look for, which is great because we do take on capstones in the lab as well, but we just don't have capacity to take on more than 6 to 8 capstone groups per semester, whereas the Connector Space can take on 30 or 40. If you were to see the lab, it's on the 4th floor of the Aldred Center. So if you're going down 16th past SAIT, it's the building that has the flowy roof on the top. Really dynamic space, really high roof, and we have a number of drones ranging from, like I said, fairly cheap, $600, up to several $1.1 million drones. Thanks to the funding from Prairies Canada and NSERC. So we're really fortunate to have a really solid infrastructure of systems. We also foster professionalism, so making sure that our own staff are working in a professional manner, especially when we get to a mine site like Curl up with Imperial. We need to make sure that we're operating in a professional manner, and we make sure that our students are also focusing on that. One of the challenges that I used to be in the Geographic Information Systems program, one of the challenges was also convincing students that communication and professionalism is a really important piece of your day-to-day operation as a student. When they come to us to work on a capstone project or a practicum position, they learn pretty quickly because they realize if they don't act in a professional manner and they're at site with us, they would get asked to leave if that happens. So it makes it real quick. Also, we, as a institute, we do not retain IP, which is another advantage for clients working with us because we basically focus on commercialization. And there we go. There's our space. Thanks. Do you want to go back, Pablo? Anyways, yeah, so that's our space, really dynamic space. We actually have a second space, you can't see it, that is about the same size, but lots of excitement. It's like this space. I was here yesterday presenting as well, and it's just the energy is great. And when you have that kind of energy, it's hard not to enjoy going to work and getting some really cool things. That's just an example of a dashboard that one of our student groups built with Alberta Wildfire, and it's just a dashboard that streams in a number of real-time data feeds from different sources. And we have this pipeline that we're proud of. We bring capstone project groups in. It's a 4-month final project. Then hopefully we can hire a few of those folks as practicum students for an 8-month work term. And then either we hire those on as full-time, but ideally they would get taken by some of our industry clients, and often by the clients that they're working on the capstone with, which really works great. We have our own safety, and confidentiality is obviously a big role for us. I'm not going to focus too much on this, but kind of just gives you a sense as to what we're doing. We sit with our client, we look at scope of work, so we try to, what is the thing that they want to do? Set up really achievable objectives, break down bigger chunks into smaller chewable chunks. And we focus on choosing the correct drone, the correct sensor, planning operations and standard technical procedures, the regulatory environment. That's really important because as you get into the larger systems, you need to make sure you're doing things properly. And then lastly, our analytical framework. So leveraging machine learning, artificial intelligence, wearables like VR, AR type things, and just making sure that the data we collect from the drone and the sensor is actionable data that they can then make decisions with. And we'll often sit with the client before we start. So we'll sit with a physicist that's dealing with subsurface geophysical data and look at what software they're using, how do they actually work, like what's a day in their life, and then we reverse engineer from there. And that's that center one is a ground penetrating radar. So that can actually penetrate down to 110 meters, giving important data to clients, right? City of Calgary, underground infrastructure, if there's areas and you're not sure where the infrastructure is, it's a great tool to help support that instead of digging up a bunch of the land. Just connecting to the labs. So I mentioned this yesterday. We are fortunate to be part of the Living Labs. We do leverage the RPAS training area quite heavily. This has been a huge win for us because it's 20 minutes from our center. So instead of flying or driving way out of Calgary to find a place to fly, we can actually operate within the City of Calgary. That's a big draw for a lot of our clients, especially internationally, because Canada has lots of airspace. And we have access to a facility here, plus a dedicated area for flight operations. We also have a strong aviation ecosystem in Calgary, RPAS as well, and lots of collaboration. So I was presenting with another drone company yesterday, a service provider called Arium Analytics, and they agree. It's amazing that all these companies in Calgary are collaborating. We're not competing. We know that there's enough work out there, and it's a very collaborative model, which is super exciting. And then we have lots of great support from Transport Canada from a regulatory standpoint to try to do more things from a drone standpoint. Real quickly here, I'm just going to finish off with a few examples. So storm ponds and rivers. So 2 examples that would be applicable to Calgary. There are several others that aren't quite as exciting, like maintenance is a huge thing, facade inspection. You could start listing off probably 100 different applications that the City of Calgary could leverage drone technology. I'm just going to talk about river and storm ponds, and this is integrating 2 sensors. One is GPR, so that's the ground penetrating radar. That's our smaller drone that we test with, and this is it mounted on our bigger system. So that sits about 1.5 meters high by about 2.5 meters long. And that can give you subsurface measurements, and in this case, we were testing it on a river system. So to get the depth of the river, and also we wanted to see the bottom of the river, and I'll speak to why that's important. And what we did was we built a custom algorithm to automatically detect the largest signal, which is the bottom of the river system, right? So it looks at contrast. And on the left there, it just gives you that profile of the system. And then we also leverage an echo sounder. So it's a dual return echo logger. So it's basically continuously sending a pulse of energy down, and the sensor can record the speed at which it comes back, and then you can get water depth. The reason we've leveraged both is in this case, you'll see the drone flying along the water pond. What has to happen is the drone has to dip that sonar about 13 to 18 centimeters below the water, and then it's vertical, and then the drone pulls it along the water. In the cases of larger environments, larger ponds, if it's 1 kilometer by 1 kilometer, that's going to be a really slow process. So what you can do is lift it up and dip it every 20 meters or 200 meters, depending on the accuracy you need to achieve under the water. So the reason we're looking at both these techniques is the sonar works really well. It gives you, in theory, the bottom and then any sediment that's existing, so it'll give you 2 returns. But if the sediment is thick enough that it gives that one return what it thinks is the bottom, we don't know if the bottom is the true bottom. So the GPR is that we're pretty confident that the GPR is going to give us true bottom, and then the sonar will give us some different levels of sediment level. Ideally, they would match, and you'd get the sonar indicating the bottom and the GPR measuring the bottom as well. But in some cases, especially with some of the mining clients where there's quite a bit of sediment buildup, they need to know that what is the bottom and what is the sediment levels. And from a monitoring standpoint, this is important because you can start to look at when you need to dredge a pond, for example. We do a lot of methane detection and quantification work as well. So just an example of showing methane concentrations, we're using one of the sensors we're using is the OPLS sensor that NASA's JPL lab produced, and it's on the Mars rover. And we've also incorporated a few other sensors just to see the capabilities and what can actually do a better job of quantification. And then this is actually another capstone project where we were looking at back trajectory of wind, so looking at wind speed and a dispersion model of that methane concentration. And then lastly, I'm just going to speak to the medical delivery project. Importantly, this is with Stoney Nakoda Nation, so the communities west of Calgary, Eden Valley, Bighorn, and Minitini, or also known as Morley. And W21C, so that's the research division of the Foothills Hospital, University of Calgary, Alberta Health Services, Alberta Precision Laboratories, and the World Health Organization. And really what we were doing is leveraging all kinds of drones, so the smaller ones I showed you earlier, and also this is our heavier lift drone. Good scale picture on the left there with the diesel fuel container and the two pilots. And just gives you a sense as to, it's just an operation. So we are doing some delivery of medical supplies and devices to Stoney Nakoda. And our big wins, we deliver PPE, pretty straightforward. We were able to deliver PPE to the remote community. We also delivered test kits, so COVID-19 test kits. This is before the at-home kits were available. So we were able to deliver test kits to the community, have them simulated, administered, return them to the lab, and we determined that there's no signal decay. So in theory, we can send these types of things out to community, have the community stay in place where they're safe, have the test kit administered, and then bring those back to the lab. And it's great. We were written up for a few of these projects in the American Journal of Infection Control, and the reason I bring that up, it's just nice because academic or technical colleges aren't always known for publishing, but it is one of our focus areas. Is if we're doing a project, we're applying enough rigor to make sure that if we need to or want to, we can actually apply to or submit journals for various applications. And then also the last three I'll just speak to is communication with mentor. And I think this is our secret of this project is we actually are integrating physicians at the Foothills Hospital into this project. And so the PPE and COVID, no need for a mentor, right? The last three, you do need the mentor. So the first one was delivering a Stop the Bleed kit. So that's gauze, clamp, and a tourniquet. We do operate in winter. It's not always just nice weather. This is in Ribbon Creek in the Kananaskis. We deliver the payload container. It's like a Tim Hortons box. It's quite light. The person you'll see will open the payload container, and Kristen will actually place her phone that she had called 911 on the tripod that's in the payload container. And she is being telementored or taught by the physician on how to apply a skin clamp. And you'll see that in a second here. And she'll have the phone on the tripod on the right. And she's applying the skin clamp. And we have a custom Zoom client. And the physician's actually teaching her, telling her how to do that. And we're using Starlink, so connectivity isn't an issue anymore. Again, another journal publication for that one. That was very exciting. And then we also did an ultrasound. So delivered an ultrasound to an ultrasound naive patient. He was able to follow the instructions from the physician, unpack the ultrasound, place the jelly, position it, turn it the way that he needed to turn it. And so all this is being documented on our procedures, so we're perfecting the process. And then lastly is our current project where we're actually looking at, asking you the question, what is your responsibility to help someone dying from acute respiratory distress? So if you're at a remote access site with a colleague and he or she suffers from a collapsed lung, falls, gets impaled, and cannot breathe. What are you able to do, right? So what we're trying to do is, or maybe you're alone and this has happened. What we're trying to do is we have an emergency procedure built. So we have, I'll just pause this real quick. We have the emergency management drone that if it's a scenario where there's a motor vehicle accident or maybe there's a train derailment, we'll send a drone in first to give situational awareness of what's happening. And then the second part is the medical delivery drone. And the idea behind this video is this is a simulation of one of our patients pretending to call 911. So that's one of the drones that we would use with a smaller payload container. So the idea is the person called 911, we can extract those coordinates from the phone, send the drone out to deliver the payload, This is just, this isn't actually a real test, this is just the simulation. So the drone stays high, so it has good radio connection between the two locations. Oops. So that was, I don't know what, I'll just finish it here. So you can, that's actually the live ultrasound as he's doing it real time. And the last part of this is he's being self-administered, teaching him how to actually do a chest tube intubation. So where to landmark on the rib cage, 3 centimeter incision. The part that freaks most people out is you have to stick your finger in to open up that chamber, and then you stick the tube in, and then he's actually applying a skin clamp to keep it in place. So we've sent, and the whole process, this is just a small snippet, but it's an oxygen saturation. So in the payload container contains an oxygen saturation, respiration, blood pressure, and then ultrasound of your lung. That's all been done in 11 minutes. And then the chest tube intubation, in theory, would be done either self-administered or you're a layperson helping somebody else, and then you'll save someone's life. So, and it does have a fully, as part of this grant, is it's building an accessible case or payload container. So the payload container will have colored bags. If you're colorblind, it also has different textured bags, labels, braille, and LED lighting for nighttime operation, with the idea that the physician, not being there, has to be able to very quickly explain what bag to pull for the ultrasound, what bag to pull out for the blood pressure cuff, right? Everything's Bluetooth, so the patient, all they do is apply the blood pressure cuff, and they don't do anything. The physician actually starts and stops the blood pressure cuff, which is pretty cool. And that's about it. So obviously, lots of funders in these projects, so we have to give our thanks to all the funders, but I'm happy to have you guys come up and answer any questions.
Any questions? Next time. Yeah.
It was a good song and dance, so you did good. Yeah.
We were worried about the rest of your slides anyway. They're all about your work with the City of Edmonton. I just want to say, yeah, thanks again. Thanks for being flexible. And I think, one of the things we talked about is, and Heather, we were already talking about it today too, is we almost want to have the reverse of today, where we have capstone students from an area within SAIT or Bow Valley College and say, here's 3, it could be digital, it could be the VR lab, right? So here's 3 digital projects or opportunities that we're exploring with the city. How can your students come and do a capstone on that, right? And the other one, Pablo, with Alicia, we've also talked about, we'll have to show the strength of the concrete that we're printing. And you guys have a tensile strength tester, right? And so how do we start working together? And so, here's the products we're printing. Every time we change concrete manufacturer, do we have to get it retested, things like that? And how do we work together on some of those projects, mostly to make it more affordable for us? But no, I think getting those opportunities. Okay, questions for SAIT? Yes, Sandra.
As usual. I have a question. You mentioned that you use Starlink in order to direct the drones into remote areas. Under what conditions could that signal be lost, and what would be your procedure to reestablish that signal?
Yeah, we're still using Starlink mainly for the communication between the client or the patient and the physician. Starlink, there's still too much latency using Starlink to control the drone, so we're still relying on radio signal. So if we use Starlink, we're looking at about a 3 to 4 second latency or delay. So if I turn the drone left, it's 3 to 4 seconds and you wait, right? And that's too long. So we're working with better latency reduction techniques to try to improve that operation, because that's the future. Eventually, it's going to be satellite-based drone drone navigation systems, in addition to the GNSS systems, the satellite locational satellites. And so radio signal is still the main focus. And we do have a number of different radio signal frequencies that we work with, like 2.4 and 5.8, and even down to 900 megahertz, as long as we get permission from ISED, who manages the frequency spectrum in Canada. And if we do lose connection, like let's say the drone is 40 kilometers away and we lose connection, it will stop and we can return home, so it can return home. So there are processes in place to make sure that the drone operates safely even beyond our eyesight, or if we lose a lost link. And we also have multiple, if we're going that distance and we're flying beyond visual line of sight, we have multiple optional landing spots. So if we do find that there's a problem with the drone and we don't have time to bring it back, we know where there are spots that we can safely land it. And we're not also flying beyond visual line of sight over the city of Calgary. It's usually remote, rural areas. Okay.
Great. Oh, we have one more, and then we're going to break.
You talked about the importance of like student integration, and I just wanted to lend also the importance of like professionalism for students. Do you know like if anybody is like ensuring that students are like, or the students' attitudes in capstones to like sort of offer insight? Because like for capstones, you're sort of forced to be in that class to work for you. So are there other ways that you're trying to integrate?
Well, yeah. Pass over to you guys for answers to that too. But I think it's a almost a multifactorial approach. So our instructors in the programs do a really good job of usually a communications course, or sometimes that's part of a project management course, and they focus on professionalism. They often have a proportion of the mark connected to professionalism with rubrics and matrix to understand what needs to happen, or if you are acting in a more unprofessional fashion, how do you improve that? And then we do more reinforcement because we already know that the faculty they're doing a great job. We bring them in and it's a different, faster paced environment. So we just reinforce a lot of those same principles. We just make sure that they understand that being on time is important. You know, the way that you carry yourself in a meeting, there are some ways that you carry yourself in meetings. And there's a long list of things, but we just more reinforce and give them feedback, and then they go back to the program, and hopefully by the end of the semester they're good. And when we do connect in clients, as part of their review of the student work, they also provide that indication as well. So they get it from the faculty, they get it from us as the research folks, and then they also get it from the industry player. You guys have anything else to add? No?
I just want to add, like the products that we provide to the clients, that we have the APECA kind of like the reviews that we do. So before we provide something to the client, we have a review process inside in our facility. So we have professional engineers in place, so they do the review. So it's a professional product that we are delivering to the clients. It's not just not the student work.
Okay, thank you. Our next panel, we're really talking about the skills that we have in Calgary. How are we attracting them? How are we retaining them? And how are we training them to be future ready? And so with that, I'm going to have them all introduce themselves. And Dave, if you could wrap it up before 12:30 on the intros, that'd be awesome. That'd be awesome. Thanks, Dr. Finch. All right, DeAndre, could we start with you?
Sure, and I'll try to be not as lengthy as David over here. Hello, everyone. My name is DeAndre Wilson. I'm the Executive Director of Work Integrated Learning at Calgary Economic Development. And so for those who maybe aren't familiar with Calgary Economic Development, we're a civic partner to the city, and we're really focused on stewarding Calgary's economic strategy. My specific role with Calgary Economic Development is leading an initiative called Talent Ed YYC, which you might have heard a little bit about from some of our previous panelists. And we're really focused on how we can connect with the various post-secondary institutions and connect them in with different business partners, nonprofit partners, civic partners, to align education with the needs of work and industry. And so that's really what my role is about. How can we make sure that those alignments are there, those skills are being developed in our future workforce, and how we can help spur innovation within our businesses and nonprofits by leveraging student talent.
Try to be less than 20 minutes. Thanks, Jason. Hi, my name's David Finch. I'm a professor at Mount Royal University in marketing. My area of research is workforce development. So I really focus looking at the development of a skills ecosystem, really at a local and community level. Since 2019, I've been part of an organization called the Learning City Collective, which DeAndre is now the board chair of, researching the opportunities for communities to play a more central role in activating and developing an inclusive learning ecosystem.
Hi, everyone. My name is Michelle Turon. I'm a leader with our talent acquisition team in human resources with the City of Calgary. And so my team works with our departments and hiring managers to fulfill their recruitment needs, talent acquisition needs when it comes to specialized positions. So, familiar with the challenges, et cetera, we face when recruiting. The other role of our team is we do coordinate our student programs with the city and connect business units, departments, managers with the various institutions on the different programs they offer as well. So certainly interested in making connection with you later as well. And I'm just going to say it right now, unlike the students, I got the questions in advance, plus I had to make myself some notes, so kudos to you.
Thanks, Michelle. And now that we're ahead of schedule, thanks, Dave. No, I can't tell you how appreciative we are to have you all here. It does feel that if there's something in the community happening with young people that is connecting them with what's next and growing them and the community, you two seem to be always there. And Michelle, I could say the same. If there's something happening at the city, your name is always on there. So we're very excited to have you all here and to share this exploration. I think one of the things we have here at WAVE is that commitment to, as we explore new technology, we also have to explore the skills that come with that. And how do we attract those new skills, and how do we build that from within? So I want to ask you, all three of you, what key trends are shaping the future of our tech workforce here in Calgary? I can ask this.
Me first. Well, I think, the buzzword that we see a lot is AI. There's a lot of implications of what artificial intelligence, machine learning, data science, all of those things could mean. It's one of the key focus areas for us at Calgary Economic Development as we look at our future workforce and future economic needs and the different key sectors that we support. In addition to that, we are really focused on the quantum space as well and what those implications could be when we think about the future of our workforce and tech and things like that. But I think overall, ultimately, with technology as a whole, there's the need for continuous learning, or adaptive learning, as we say at Learning City, and really building that capacity in our workforce to understand that they need to continuously learn, continuously change. And I think a big part of that, and one of the reasons why Calgary Economic Development is championing the Talented YYC initiative, is really understanding the role that industry, nonprofit, and our different civic partners play in that. Because really our workforce is driven by the needs of work and industry. And so how can we make sure that the different training programs are aligned to meet those needs and are developed in a way that allows those folks that are going through those programs, those different learners at whatever stage they are in their career, have that adaptive capacity to meet it. And so being able to embed work-integrated learning principles in these different programs is really important so that students and learners can build those transferable skills or adaptive skills that they need. So whether that's about critical thinking, communication skills, recognizing that they have to be continuous learners, those are the different types of things that we really want to see as we look at those different trends in technology. They're constantly shifting, constantly changing, and so that adaptive capacity is really key to meet and align to those trends.
Good answer. So I would challenge the question. I think we need to drop tech from that question, because one of the things we've certainly seen in the data over the last decade is this concept of adaptive capacity is the killer skill. It's the skill every employer wants regardless of size, because they have no idea what next week is going to look like, let alone next year. The challenge with the traditional learning system is we focus on what I call vertical skills, skills that are really discipline specific and often industry specific. And what we saw in 2014, and Calgary got a precursor of what the future is going to look like, is when people not only build a career and build a life, but build an identity tied to a very specific, often functional task or tied to a very specific sector. It's difficult to decouple themselves from that sector when the sector no longer needs them, right? They are in fact become victims of the externality because they no longer have agency, because they are dependent on global market pricing for oil and gas, period. If you build what we call horizontal skills, which is tied to enabling skills, which allow you to in fact have agency, work across sectors, work across disciplines, that's what's essential. And unfortunately, the current educational system, formal and informal, spends little time really focused on developing and establishing agency for employers and employees, and very little time building that lifelong mindset that is essential. One thing I always talk about is 50% of 5-year-olds today are going to live to be 100. My kids are going to be having 60-year careers. The thought that what they learned in a classroom when they were 20 is relevant to them when they're 24, let alone relevant to them when they're 70, is absurd. And the entire system is assuming there's about 5 years of learning that develop the skills that can be monetized for 60 years. And it's just not the reality. And that's a mindset problem, but it's also a systemic problem we have societally.
Yeah, I totally agree with you on those softer skills, right? Tech's important, but it's that critical thinking, that being adaptive, that emotional intelligence that is really going to be key not only in tech but other positions in the future as well. And that's what organizations need in order to adapt and adopt quickly. I'm just going to add a couple of things to what you said. From an HR perspective, I mean, we've always had demographic shifts in the workforce, but again, that's going to continue to shape the workforce of the future. Millennials, Gen Z coming into the workforce now have different values than others do. So how do we present ourselves as an employer to match those values? And I think the pandemic taught us too about the remote and hybrid work styles. That's going to shape how work is done in the future. Do I have a desk to come to every day, or can I just go anywhere and do my work? So that's something that we're shifting at as well.
And I think, Dave, you were starting to get into that almost micro-credentialing piece, right? So, you know, we both started our career, that's how we met, was we were both Betamax technicians and repair technicians, and we've since transitioned from there. But Dave, do you think that post-secondaries, universities and colleges are prepared to deliver adaptive workforce required for the future?
Not only are they not prepared, they have absolutely no ability to adapt to meet those requirements. I shifted into academia after about 20 years in industry, and remember, and this is unique to universities, we sign 30-year-old PhDs to lifetime contracts, right? Think about that. Lifetime contract for a 30-year-old PhD, because when they secure tenure, they're going to be there until they're 65 or later, right? When I first discovered this as I became a professor, I realized, boy, looking back at my undergrad years, I remember why I was looking at case studies from 20 years ago, because there's very little incentive to update them. Now, what I've seen in the system as a whole is there's an enormous number of innovators in the system, but we have to focus at the bottom, not the top. The institutional inertia, the structures in higher education. I sit on the Ministers' Council for Higher Education and Skills, and the answer is we have 26 post-secondary institutions that are not a system. The common thing I say is stop talking about this as a system, because it's not a system. It's 26 silos working independently. In those independent silos are additional silos, right? And then we expect students to be able to navigate and maximize their opportunity. And here's the business case in higher education that, I'm a marketing prof, so I look at everything from a sustainable competitive advantage perspective. A 4-year university degree in Alberta takes about 10,000 hours of work. Okay, it costs about $80,000. The average student debt is $35,000. Okay, that's an opportunity cost, right? A third of the students who start post-secondary in Canada never complete. Okay, 40% of those who graduate from a university 4-year degree are underemployed, meaning that they've taken the same job out of university that they could have taken out of high school, and that cost them $80,000 and 10,000 hours, right? That's a terrible business case, right? So the answer, I spent the first decade in higher education, Jason, trying to break the system from inside. And I'm a big believer of, coming from my background, the tech space, we've got to disrupt it externally, right? And disrupting it externally is recognizing 85% of the learning system is actually outside of what we would call certified learning, right? We have the capacity in the system right now. It's just not recognized. And we don't identify and leverage the competencies that are developing in those non-certified and informal learning opportunities.
Am I supposed to respond to that?
Yeah. You want to respond to that?
I can say a few things. As David said, we do work closely together as a part of Learning City. I always appreciate David's comments as someone who works in a post-secondary institution, but
tenure.
Yes, I was going to say that.
As I mentioned, my role is really to work closely with the post-secondary institutions, and echoing what David said, there are significant silos, but there have been a lot of conversations and active work now to try and break down those silos, which is a big part of what Talent at YYC has been trying to do. But I think to echo David's point, again, it is really important to have that external lens to it and to have that industry-driven focus to it. That's where we've seen the traction, because within those institutions, as David alluded to, there's so much bureaucracy. There are systems that have been in place for 20, 30, 50 years that have been established. And so the way to kind of break through those is to show from that industry, that economic lens, why we need to change. And really, taking that lens from industry, nonprofit, civic partner perspective, that these are the needs that we have. This is the reality that students, when they complete your programs, will come into. We need to make that shift. And so that is what we've seen. We were sidebarring earlier. One of the ways that we do see that is really through a lot of these work integrated learning programs, and especially through things like capstone projects and different sort of classroom projects, where we have those innovators like David, that would look at these alternate models of learning and allow students to have that direct exposure to industry and gain those skills. And what we're really trying to do with Talented YYC, and I guess more broadly with Learning City, is how can we start mapping all of those different opportunities to break down those silos, both within those post-secondary institutions as well as those non-credential learnings outside of the post-secondary institutions. So I think that there's possibility there, and I do think that there's progress being made, but it has to come from both of those perspectives, both the credentialed learning as well as the non-credentialed side.
That's great. And you know, we heard earlier from Alicia and Named Vasquez, Dr. Named Vasquez, and the skills that are happening with robo manufacturing or robo fabrication. We're seeing it with the AI skills that are necessary. Michelle, you know, we're seeing lots of micro-credentialing. We're seeing, you know, the city is really good at offering those learning opportunities, but what are those challenges you're facing with upskilling the workforce?
Oh, with upskilling the workforce, well, specific to the public sector, right? And I won't say specific to City of Calgary, but certainly we see many of these. So for upskilling, the first is budget constraints, right? There's probably so much that we want to do just in terms of the new technology that we want to investigate or implement, but we have to be accountable for the money that we have too. So it's finding that balance in terms of where do we invest those dollars, right? I'm going to flip my page here. I think as well, just in terms of upskilling employees, and I'll preface this with saying, upskilling is important, right? We have to. We can't. There's going to be challenges to recruiting, so we have to invest in our own workforce. But there could be resistance from change, or resistance to change from that workforce. People who may not want to learn those new skills. So how do we show to them what's in it for them? Why this is important to learn something different. There's competing priorities. In the public sector, we have such a vast array of services. So while upskilling may be organization supported, where there may be buy-in to it, something else is always happening. So how can we shift those priorities to make that upskilling the main priority? Because that's not always going to be able to happen. I think too that, you know, in terms of upskilling, it's finding the right upskilling opportunities. Is what's out there in terms of training or what's available specific and being able to address the unique needs of the public sector and the technology that we want to go into? Or is it better to hire a consultant, create something customized, which then again leads to some of those budget constraints you have. So, you know, there's quite a few. Retaining talent. You know, you upskill your talent that you have, you convince them that we want to invest in you, they might then be scooped up by another organization that is looking for people with those skills too. So those what I would consider the main ones. You may have others that you want to share.
No, that's great. Like, I think you're starting to get into that, that there's retention for sure, but then we're competing with all this growing tech ecosystem here that's screaming for talent. So DeAndre, how is Talented YYC playing a role in attraction of talent and building talent?
Yeah, so, you know, at CED, as a part of our talent strategy, there are 3 streams, which I guess typically for talent there are attraction, retention, and development. And so, you know, a big part of our strategy is, and especially for Talented YYC, we're really focused on that retention and development aspect of it. And so when we look at the talent that we have here in our city, how can we ensure that we're upskilling? How can we ensure that we're retaining those highly qualified young people, especially who are coming out of our post-secondary institutions, and connecting them in with opportunities that will allow them to continue to develop those skills on the job? How can we pair them with mentors that will continue to allow them to grow? But at the same time, from that talent attraction lens, recognizing, okay, where are those gaps within our current ecosystem so that we can bring in folks that can fill in some of those specific points that maybe we don't have currently in our city. And so that talent attraction piece is part of a broader strategy, our broader economic development strategy as well. And I think most folks will be aware of our new city brand, our Blue Sky City. And so a lot of that is really how are we looking at comparable markets to say, okay, they might have some of that talent that meets those gaps, and how can we bring them here to Calgary Calgary and fit them into our ecosystem to meet those specific needs. But really, it has to work together. And the priority is really looking at what do we have here in Calgary and how do we continue to grow that. And so that's a big part of what we're doing with Talent at YYC specifically, looking at all of those different levels of post-secondary institutions, but really, as I said before, looking at those needs of industry, public sector, private sector, and nonprofit, and saying, how can we connect in with the talent that we currently have, because we do have a vast array of talent, and how can we get them into those roles? David mentioned before about when the oil and gas downturn and the folks that were tied to a specific sector felt as though they had no place to go. One of the initiatives that we piloted and championed through Calgary Economic Development was the Edge Up program, and how we could transition oil and gas workers into tech fields to help them realize that they're not tied to a specific industry, but they do have those transferable skills, those adaptable skills that could help them fill some of those needs. And so really focusing on that, and then understanding from within that ecosystem, okay, where are some of those key points where we can bring folks in that can mentor our talent here and get them to that level that we want them to be as we continue to innovate in our city.
So going off script, you talked about the importance of collaboration between post-secondaries, industry, and organizations like Calgary Economic Development and other NGOs. Where are you seeing that happen? Where are some of those big employers like the City of Calgary and post-secondaries and NGOs and CED and industry coming together? Do you have an example of that kind of collaboration yet?
But yeah, I mean, it's so important, right? And as I mentioned, so my role is really focused on work integrated learning, and so that's really the point that we've been focusing on, to bring in those collaboration pieces. And so a part of that is around, what are some of those key challenges at the city that need to be addressed? And so how can we bring in post-secondary partners with students that are working on some of these different things, that are learning those things in their classroom or doing some of this research, align with different professors in those institutions and bring them together, while also bringing in some specific industry partners that might be able to provide that specific mentorship to the students. As you're aware, we've done challenges with the city. We did one earlier this year. That was back in, I think, February, really focused on EDI and the equity index of the city, and how can we address some of those needs, leveraging tech and data, and brought in students and brought in industry partners as a part of that. We'll be doing another one that's really focused on clean energy and net zero with the city, and looking at how we can use different sensors to identify some of those different needs, and bringing in students that can work on some of those challenges. And so it's really about how can we bring these different folks with the different skill sets, these students that have the capacity to work on these challenges, that also allows them the opportunity to grow those skills, and bring in, the folks that actually have the needs, whether it's folks at the city or folks within nonprofits or different aspects of our ecosystem. And so really working together to bring those folks together. And that's really what we try to do at CED. Like we kind of brand ourselves as a convener, bringing those different folks together. And so this is just one example of how we've been doing that.
Okay, so that's the institution, and yes, you can. Yes, you can.
So where DeAndre is going, where the fundamental challenge and opportunity here is the current skills ecosystem, the traditional learning system, is a product of the Industrial Revolution. It was designed truly to drive mass literacy. So what did it do? It identified age as the common denominator, and it created a very efficient production process to push young people and adolescents and young adults through a system at volume. That's what a mass production system does, and it did it exceptionally well. And we are our incredibly literate country. The challenges, and most organizations, industrial organizations, followed an identical model until the late 1990s, right? Which is fundamentally framed around an idea called closed innovation, which is, I can do it myself, right? Fundamentally. I'm at the Mount Royal University, I'm at the U of C, I'm at the City of Calgary. I can do it myself. When you start reflecting on the principle of open innovation, and the most obvious example of open innovation was when Apple opened an app store and turned their iPhone fundamentally into a gateway for millions of developers to develop content and applications through their system, in which they took a nice 25% cut as essentially the distributor and the conduit for those systems. But you compare that to BlackBerry, right? That kicked ass with the BlackBerry Messenger, and that was about it, because their model was internal and isolated. If you think and say, let's think about how we would do that from a skills ecosystem, right? So that was some of the work we did with CED. We audited the skills ecosystem. So when we talk about learning, I generally will ask questions. Tell me your most transformative learning moment in life. I can tell you probably in one hand, the people have said it involved a blackboard and a classroom. It often involves being on a field, being on a stage, being in a church, mosque, or synagogue, traveling, climbing a mountain. Those are the transformative learning opportunities that are rarely recognized. And that's the problem, but it's also the opportunity. Because if we think about learning as moving from this closed, centralized model to something that's highly distributed, right? We move from 7 post-secondary institutions and a few hundred K-12 institutions. The city has 3,000 organizations who self-identify learning organizations, including WinSport, including any arts organization you may know, including every church, mosque, synagogue, and temple. These are all places people learn. They're just not recognized, right? That is the opportunity. Then we overlay 47,000 employers in the city on top of that number. We have 50,000 learning nodes in the city, and it looks like the internet before the internet, which were all these computing nodes that had no connectivity and ability to, in fact, interact together. If we build the underlying structural capital that connects these learning nodes through competency assessments, we fundamentally unlock the capacity. And more importantly, we unlock and create equity in the system, because we can talk all we want about post-secondary institutions. A third of Calgarians will never, ever have an opportunity to step in one of those post-secondary institutions. That is the untapped labor force in this city. So this is why we need to pivot the conversation away from a very expensive premium path that is slow and not responsive.
And actually, Dave, we're gonna build on that, David. So then, how will learning need to adapt? Like, if you take what you just said, what does it, like we talked about organizational change, what does that look like for the student?
So you asked for an example, and there are some really interesting things happening in the city. The thing about Calgary, different than most jurisdictions, is we try stuff, throw crap against the wall, and see if it works, and sometimes it doesn't, sometimes it doesn't. So last year, I had the opportunity to work with the City of Calgary, with Calgary Economic Development and Talent at YYC, and a variety of other partners, in which we moved 1,000 Mount Royal students to Bow Valley Square. We had some underutilized office space. I had enough legitimacy internally at Mount Royal that said, what if we move 1,000 students downtown? Let's see how that happens. And then we signed 70 employers to co-locate with us on the 5th floor of Bow Valley Square. And then we taught over 35 classes there. Inception U also taught classes there. We hosted events for over 4,000 people. What it identified is the legacy challenge we face of the industrial learning system. So what that model assumed was that students would have agency to be able to lean in and be able to recognize all the employers there are also learning agents, right? We expected all the employers to actively engage and recognize they're also educators. And we expected the educators to adapt their learning because they no longer have a blackboard. And they didn't. All three fell immediately back. It was $1 million pilot. They all fell immediately back in their traditional roles. The educators taught identical courses to what they taught on campus. The employers rarely showed up because it was easier to work at home. And when they did, they were often disisolated by themselves. And the students viewed educational as a transaction. They came to class and left, and like they do on campus. And that's why we've really got to unpack and create a whole new model that leverages all three systems, but it's not going to be a slight tweak of today's model. It's got to be fundamentally disrupted.
So now we've talked about what the institutions can do. Michelle, what can public sector organizations do to overcome the recruitment and upskilling challenges?
Well, you know, when I didn't get into this earlier, some of those challenges from a recruitment perspective is like competition is fierce, right, for the same people. And so we recognize that. We may need certain skill sets, but thousands of other organizations do as well. So one way is just trying to figure out how do you reach those passive talent. And what I mean by that is there are people who are happy where they are. They're not necessarily looking for a new job. They're not looking at your job board. They're not networking. They're just good at what they do. And so how do you find them and how do you reach them? Because I think that would be important. And then not only are you doing that, but all the other organizations are doing that too. So how do you convince them to consider your organization to go to? So really building your brand as an employer, trying to share what you can provide them, the value that you're going to give to them, what's your employee value proposition is certainly important in that. Definitely, you know, one challenge in recruiting, people, especially if they're in high demand, is your recruitment process itself. Or do you have a lengthy recruitment process? What's the time from the initial application all the way through to job offer? If that's long, you got to shorten it greatly. And sometimes that's hard, right? Because managers are busy. It might not just be that your recruitment process is long. I talked about priorities later. They just might put recruiting on the back burner because there's another fire to put out. But you have to be very, very mindful when recruiting that this group of people that you're trying to attract is looking at other opportunities too. So move quickly. Right. What else? I think as well, partnering with post-secondary. You know, we've talked about that a lot too. Talk about that skill shortage in the marketplace. So you might not be able, there's a demand for people outweighs the supply for what you're looking for. So I really do think building those post-secondary partnerships is important. Like at the city, we're trying to take advantage more of those capstone courses where, you know, students are being exposed to industry-specific problems, getting that experience, but then we as an employer gain from that as well because we're learning new things, right? And so what you're doing is you're building your talent pipeline before they're out in the world getting that experience, making the connections, and hopefully convincing them to consider the public sector as an employer. Hate to say it, but sometimes the perception out there is the public sector is not an opportune employer to work for. You know, we're considered slow. I don't think so. But, you know, there's a perception that we could be considered slower. There's limited, you know, our salaries below market. But that's not always the case. So it's really, once you're building that pipeline from when they're younger, showing them the value. What's the purpose of the work that we do? What's the impact that we're giving to the community that we serve? That value is sometimes greater to people than a salary or the perquisites they get to. So just a few.
No, and I'm really happy that you said that, Michelle, because I did want to just piggyback on that and really hone in on, you know, we talk about there's this like war for talent. And yet at the same time, as David kind of alluded to before, there's a ton of people who are underemployed or unemployed. Like that number is also going up. And speaking back to, you know, the Learning City pilot with the Open Learning Lab and the challenge that we had there where, you know, we had all of these businesses sign up to be a part of it and rarely showed up or didn't even recognize that they could also be a part of being educators for these students and building the talent pipeline. I think that really is a big part of this shift that we need to have is that every single one of us can help develop the talent that we think we need. It's almost impossible that you're going to get a perfect candidate for all of your roles. Like that's never going to happen. And for some reason we've shifted to this mindset where a lot of folks when they're into recruiting, like, yeah, we want someone that meets 100% of the requirements and we're going to go and, you know, scout and poach people to have that exactly perfect person when there's so many opportunities to exactly to your point, potentially work with post-secondaries or, you know, work with other non-credential organizations to find that talent. And really, if you just invest a little bit in helping them with, you know, learning and adapting to your work environment, you're also going to get probably a more loyal employee, but you're going to be contributing to this skills ecosystem and having more of that adaptive capacity all across our city. And so I think that's really a big part of the mindset that we need to continue to shift, especially, like I said before, a lot of this needs to be like industry driven and driven by, you know, the employers, because we can't just expect talent to just be ready-made and show up at our door. We're all a part of this ecosystem to continue to develop those skills and create that adaptive capacity across our city.
We call those the unicorns, right? That's what that
Exactly.
unicorn.
Exactly.
Dave, I'm guessing you had something you wanted
Yeah,
to add.
I was just going to say this idea of informal skill development is critical because the workforce and the workplace is changing so dramatically, whether it be distributed work teams across different locations, whether it be working in an office that once had 20 people and now have 3 people in it. And that's where we need to really think at optimizing and preparing students for that environment. The one thing I've observed post-pandemic, and it's a significant problem, is we have young people moving into a workforce in which we would have all had the privilege of mentoring and coaching, meaning that you walked into the kitchen and there was somebody there that had dealt with your problem before because they'd been there 5 years or 8 years, and you're having a coffee with them, chatting about them. Now we're having 22 and 23-year-olds come to an office. Often, from my experience, especially in the creative space, they might be one of 3 people there, right? And the office is working primarily at home. They have no one to mentor them, no one to coach them, and they're lost. And that is going to be the long tail of COVID unless organizations put into place some supports that in fact allow them and coach them and recognize. I tell my students, never use the term graduate. And so all our students do is transition on a Friday from one learning environment to another on the Monday when they in fact walk across that stage. But they're walking to a place in which they have to have absolute agency because no one's going to tell them where to go, but there's no one any longer there to mentor and coach them, and that gap's a problem.
Yeah, and I think we've seen that even here, right? Having the co-op students, having the tech-savvy folks that we have on the Smart Cities team. We've got tons of business experience on the tech. Some of our folks have been in startups or their community volunteer pieces like CivicTech, YYC. Those folks are here, and they're much younger than me. And so I found that I think if you're over 40, we need to find someone between 20 and 35 to be your mentor, right? Because there's so much that we're learning from them. Yeah, right? There's so much for learning for them. But then also I've seen, even since we've been here the last 8-9 days, that this is an inspiring much out of it because they want to be here. They want to be playing with what's here. They want to be experiencing it. They want to be working on things. But even for our own staff team to keep them engaged, finding something that they can, like work can be work, but you have to be find something in each of their portfolio that's challenging and something that they can be passionate about. And we have to make it a fun place to work. So, this team in particular, IT in the city, is mobile, right? And so you can't hear, there we go. Better? Thank you. I've never been told to be louder before. That's awesome. So we're pet friendly here. We're trying that out with the city. What happens when your workplace is pet friendly? Does it make you less anxious about leaving your dog at home or your budgie, Ross? Right? So okay. So we're going to start wrapping it up, and I want to go to some questions. But before we ask the audience too, I want if you're asking a question, if you could also tell us what you think the next big disruptor to our tech workforce or to our workforce in general will be over the next 10 years.
That is a I think as we said before, and we've seen it, in the past several decades, like the change in innovation, the pace of innovation is just so rapid, so much more rapid, and that we've seen since the 90s, right? Like since the 2000s, it's literally grown exponentially. So to really pinpoint exactly what it will be in the next 10 years, it will be pretty tricky. But, you know, I do think, kind of going back to some of what was already said before, that we saw through the pandemic this shift in, do I really need to be in the office? The rise of remote work. But we also saw a lot of this sort of depersonalized sense of work, I guess. And I think we're starting to shift back into people wanting to have more of those personal connections. You know, tech is allowing us with AI and, you know, generative AI especially, to have more things that are tailored and customized for each individual person, potentially based on, you know, what they put into that AI. And so I do think that we're going to see some trends there around moving back towards more relationship-based work, more personalized work, but still that flexibility in work. And so I think that's going to continue to be more and more prevalent in what we see. And so we have to make sure that employers can adapt to that, as well as, you know, our workers can. And so we have to think about that from that perspective in how can we make sure that we are creating workforces that are aligned to sort of the individual needs of each employee, while also maintaining that level of flexibility. I think we all know Calgary is one of the fastest growing cities in Canada. You know, we have a large immigrant population here, and so understanding and adapting to that as well from those individual needs will be really, really key. And we see that as well in our international student population as well, though I don't know, the feds may have one thing or another to say about that with some of the international student visas going on, but I do think that will continue to be prevalent in what we see for Calgary. And so being able to support each individual, wherever they're from, regardless of if they've been in Calgary for generations, if they're new to Calgary, if they want to work in the office, if they want to work from home, if they have different language needs, if they're neurodiverse. These are all different things that we will see as a shift moving forward, and leveraging technology to support each individual worker will be really, really key.
I think probably for most people here, this is before your time, but I remember 1992, I was at Bell Canada, and I remember I got my first email. I remember going to my first website, and we didn't have one, and we were Bell Canada, because we didn't know what it was. I see 2024 as 1992, meaning that if you looked at what happened between 1992 and 2002, we were still 4 years away from Google in 1992, right? If you look at the disruption that's happened in the tech sector over that decade and how it fundamentally redefines society and the workplace, that is, I believe, the opportunity we have here at a city level. So the equivalent is we've historically, as a city, assumed that's not our job. I always tell the story, I was presenting some research to City Council once, and the first question to me is, Dr. Finch, I think you're in the wrong place, because if you're here to talk about education, you should be talking to somebody in Edmonton. That was one of our city councilors, because they believe that education's a provincial responsibility. That's why we did the audit that identified 85% of learning, in fact, is local, right? But it's highly fragmented, it's fractured, and there's no identity. If we can harness that in the next decade, that's what will set Calgary apart.
What do I add to that? Yeah, I think that, you know, totally agree. I do see more centers like this between government, between public sector, between private organizations that will help to drive us forward at a quicker pace. Yeah.
Great. Okay, so we'll open it up to any questions. Before your questions, if you could just tell us what you think is the next big skill or the next disruptor that we're going to have to upskill for. And then, yeah, they'll pass over to you. Yeah. Any questions? There's a thorough, yes, in the back.
My question to you is that gap that we found everywhere, that we have communication between faculty, industry, and all these institutions now. And what are the steps, what are the process to solve that?
Okay.
That's the big gap here. I have a attended many conferences. Last week exactly with the law enforcement, and you can see the gap between them and computer science. Yes? Just because there is no communication there.
Yeah.
There is no just lack of communication. There is that gap. How we do the industry, control system, computer science, universities, same problem. People trying to build or reinvent the wheel. Yeah, let's say that. I saw the police trying to learn all this stuff that computer science learned in many years.
Yeah.
Why are we doing this? Why are you spending hours learning something instead of doing your job? Why we don't work together? Or why, as you say about faculty, the education institution, why our curriculum doesn't have yet that incorporated to teach the lawyers that particular area? Yeah, why our curriculum is obsolete to that gap that we have. We're looking at AI, yeah?
So how do we bridge the gap between industry, government, community, and education, and the skills gap and also the need to keep doing work at the same time?
Sure, why not? The incentives have to be in place, and they're not. I really believe the innovation, again, sits at the bottom. There's an enormous number of innovators, whether they are HR managers, whether they are coaches at WinSport, whether they are dance teachers, whether they are university professors. The challenge, if we look at the kind of traditional system, is especially if we look at the post-secondary system, is we start at the top. Let's negotiate an agreement between the University of Calgary and U of C and SAIT. That will take 3 years, period, right? But I'll give you an opportunity where I think, and then again, this is stealing from the private sector. I always say it'll take 3 years to negotiate institutional agreements. It'll take 1 beer to build a partnership between 6 people that want to collaborate, do fun stuff together, right? So the incentives have to work, meaning that, and I'll give the Alberta government credit. They established something called the Alberta Centre for Labour Market Research, which I'm part of, and it's being housed at the University of Alberta, but it's not a relationship or partnership with post-secondary institutions. It's a partnership between 25 individuals and organizations that want to collaborate. And so looking for that low-hanging fruit is how we act fast, but the incentives have to be there to get us there.
And the relationships have to be there, right? It can't just be positional. Yeah.
Yeah, and I think just to piggyback on that, on the incentives, it is really key. I think, the incentives are the starting point towards that culture shift mindset. And I guess I'll also give a small kudos to the government of Alberta as well, because, they did put in a mandate for Alberta 2030 for every post-secondary institution to have work integrated learning in every single program by 2030. So they are really trying to push the post-secondary institutions past all of this 50-year bureaucracy that they've had and say, you have to work with industry. You have to do that collaborative type of learning. And so that's the start, breaking down some of those silos. But at the same time, yes, you do really need those innovators, those folks who are going to kind of be the first to adopt that change, to start moving things forward. And I do think, as I said before, that each and every one of us can be that. Like every small business, every nonprofit, every civic partner, everyone in the public sector, if they're committed to being a part of developing those new skills, there's nothing stopping you from reaching out to an innovative professor to say, yeah, we're going to do something a little bit different. And, Talented YYC, I'll do my plug, my Talented YYC and Learning City, we are really trying to help be those conduits and connectors to make that happen, both in the credentialed and formal learning space and in that informal learning environment as well.
And I think that work integrated learning, doing feedback sessions with the students afterwards, right? Because again, Saksham is a brilliant computer scientist, but after his co-op, when he goes back to school, they're going to ask him, so how did things work out? And he said, well, I had all this opportunity and all these tools when I was working at school, but then when I go to the City of Calgary, I'm having to do these tasks with standard computers and standard software. I don't have the compute power. How do I need opportunities I need to learn how to work within restrictions, right, and constraints, and within budgets, right? And so that'll be one learning I think he had. The other one, I'm speaking again for my youth mentor, just file management too, right? Like you're creating so many files, but how do you store it, and then how do you pitch and sell those ideas, right? But do we take the opportunity as post-secondaries to learn from our students coming back?
Jason, you want to talk incentives and disincentives? So
Yeah.
here's the challenge to everyone in this room. Stop asking for a university degree unless you actually need a university degree. You want to create a disincentive in the system. People are chasing the pot of gold because their parents are telling them to, because employers historically have asked for that university degree, right? That university degree is a weak, statistically weak proxy for performance, and you don't need it. Sure, if you're a medical doctor, an architect, or an engineer, go for it, right? But the vast majority of roles in society do not require a university degree. Focus on skills and competencies, regardless of how they were developed and regardless of whether they cost you $10 or $80,000.
Yeah, yeah. And sometimes you'll come out of university with a 4-year river guide degree and then find out the rivers are frozen most of the year. And now we're working in IT. Okay, with that, I'm going to thank you, the three of you, so much for coming out today and sharing this.
I just wanted to invite the three of you, since you have mentioned a lot of challenges, that Lance down there has an AI application that he thinks he wanted to get your opinion on it, because it could solve some of the problems that you guys face. So if you had a minute, if you could go down there and yeah, you can take it there.
Yeah, the AI. It's an AI interview assistant, and Jeff, the AI, will be asking you questions about the wave and what's next. All right.
This one he's putting together is specifically for education.
Oh, okay.
It's not the.
Oh, good. Okay, so you get a custom program. All right. All right. Can we just give him a round of applause? Thank you so much. And
I'll be talking about the first project we ever had on virtual reality in dementia care. So let me just put this on. Let's put on our VR glasses. So it's about shaping tomorrow's healthcare through virtual reality, and it's Bow Valley College in partnership with Kaleidoscope XR. So our project summary, the applied research and learning outcomes using a multiplayer virtual reality role play and comparing it to the conventional, traditional way that we do role plays. So Caregiver VR is a VR platform that's multiplayer. It gives you an immersive sensory experience. So you're able to see sensations of dementia, like hearing sounds, tremors, and visual hallucinations. It's open and unscripted, so you go in there with critical thinking and problem-solving skills. Let's also see more into Caregiver VR, if we can get the audio a bit up. Thank you. All good. Should I restart that?
try it one more time.
Yeah. Yeah, go for it.
For VR emerges as a powerful.
Oh, it's mine.
It's a very quick onset versus a chronic progression.
Utilize objects to enhance scenarios. Whether at home or in residence, challenge your trainees to deal with any circumstance in a safe environment to develop transferable skills by acting and communicating authentically in real-life situations.
Hi, Howard. How are you today?
I'm okay, thanks.
Are you ready for your shower?
I don't know if I want to have a shower today.
Alrighty, how about, sponge bath?
Our dementia simulation mimics actual symptoms, pushing trainees to communicate effectively while facing real-time visual and auditory hallucinations. Is the condition, while another takes on the role of the caregiver.
Hi Dawn, are you ready for your shower?
I don't know if I feel like a shower today.
I remember when my son walked his first few steps. Good times.
Okay, well, how about we try a sponge bath? Would you be okay with that?
Step into the shoes of those living with dementia. Caregiver VR. The future of immersive empathy training is here.
So yeah, that was Caregiver VR. And of course, let's see the results when we compared VR and conventional role plays. So we can see here that in regards to comfort, there's actually not that much significant difference with VR and conventional. But in terms of interactivity and most real-life engagement, VR roleplay had a significant difference. And it led to more beneficial ending dementia care. And of course, we also have some student responses. So these are more of the qualitative data that we got from the students who were our participants. One of them said VR makes a difference when it comes to understanding what an individual with dementia may experience, which can help to create better techniques to help them go through this. Utilizing both VR roleplay and conventional would still be best. Some cannot be learned virtually since we are dealing with people. And VR also helps a lot in experiencing real-life situations. It's easy to practice with VR in building confidence and communication skills. VR added the challenge of perceiving that the person I'm talking to was elderly and had dementia, and really helped set in the tone of the scenario. I gained valuable insight into their experience. And this was one of the best. I work in long-term care and initially found it challenging to understand the behaviors of people with dementia. But after experiencing VR, I became more empathetic. The visual and auditory hallucinations helped me see how chaotic and frustrating their world truly can be. So this is the study that we made. That's it for this presentation. This is our team. If you have any questions, I'll be over at the demo room. And I also have with me a VR headset. We can try out Caregiver VR if you want to. So thank you again, everyone.
That's great. And I think what we're seeing already is we've chatted with Bow Valley, and Val, you've been on those conversations where, again, how do we get these city opportunities in front of students? And we've got one right now you'll see in the VR room where Parks asked and Heritage asked us to explore a way of capturing the way Olympic Plaza looks now. We all know that there's a major renovation on Olympic Plaza, so we had Chase and our survey team, and I think we used about 3 or 4 different ways to capture in 3D or in VR, multiple ways to capture what the park looks like now. And then how do we make that interactive? Could we work with Bow Valley or SAIT or the U of C and say, hey, what's a good way to invite the public to share and add their input? Wouldn't it be great if you could walk through it virtually, but then just like pop up video and someone say, oh, here's my memory of 1988, right? And have images and videos from the Olympics when Monique was hanging off a telephone booth in the middle of the square and celebrating. We were 15, we were young, 13. I was 13. You were younger than that. And right, but or say like here's an image of what it looked like in 1886, right? So how do we develop, take the data we have, work with post-secondaries, and turn it into a really immersive experience? Great, Jez, thank you so much. And again, we'll just be over by the VR room after our next presentation.
Hello and welcome everybody. My name is Kevin, and we are the Fantastic Five. On October 6th. We were deemed best overall at the GenQ Quantum Computing Hackathon, And we'd like to share with you our presentation because we think that this could be a tremendous benefit to the city. Let's begin with a story. Imagine John.
It's quantum superposition between two states.
All right. Imagine John. He's had a long, hard day, and all he wants. Oh no, there's been a huge dump of snow. That means slow traffic with lots of accidents, made 75% worse by delayed plows. But that's not the worst of it. There's no way he's going to be on time to pick up his child from the daycare. This makes John so angry. So what can he do? Well, do you want to be the one to take his call? Do you? Do you? Me not. But real people that we interviewed during the hackathon are in the same boat. Alice here has given up calling 311. And Tom, who's a doctor, has been locked in so many times he's always worried that he's not going to be able to get to the hospital. And Emma, knows that there is a road clearing update map, but it's not really good for driving with. And they're not the only ones. According to the latest citizen satisfaction survey, 98% of Calgarians say that road clearing is a priority, is very important, but only 70% think that the city's doing a good job of it. Only one other service ranks worse in those two categories, and that's affordable housing. What's more, in 2022, additional $10 million was added to the snow clearing budget. Hasn't improved it. This is a red flag. When the GenQ Quantum Computing Challenge came up, I saw this as an opportunity to help my fellow citizens tangibly. I've gotten stuck in the snow too. This was personal. Japnit, is our team up to the challenge?
Yeah, we are. But the challenge is not as simple as it seems. There are other factors in it, including road width. Not all Calgary roads are the same width, as well as real-time traffic conditions, or the fact that it's harder for snowplows to take U-turns. There are other things like some roads are priority, and there needs to be certain priority zones, as well as some roads have construction going on. So we had to account for all these different variables, which made the problem very complicated. But don't worry, because this is exactly what we wanted to do at the GenQ Hackathon, and our team was up for the challenge. We had 2 software engineers in the team, we had a few quantum people, as well as a business thinker who could make sure that we come up with a viable product instead of getting stuck in the theoretical quantum stuff. And after juggling work meetings, 2 sleepless nights for Jamal, and I think we're in like quantum superposition again.
Let's use the computer.
Yeah, let's use the computer.
Superposition is everywhere, right?
So after 2 sleepless nights for Jamal, juggling work meetings, submitting the solution after literally 500 tries, singing on the rooftop, and making 50+ Canva slides for our 3-minute presentation, it was all worth it because we ended up winning. And not only did we win the sub-challenge, which was the snow plowing sub-challenge, but also the entire hackathon. Sorry guys, something is up.
Yeah. It's not you. Like this is we just moved in last week.
Okay.
Our internet is hanging on by a thread.
Okay. So this is the solution we came up with in just 48 hours. Our vision was to disrupt the current road planning mechanism used by the city. This would help not only the city, but the citizen as well as the snowplow provider, because we would be able to optimize the routes in a way that we clear the routes faster while saving CO2 emissions and saving fuel. So this is our solution, Street Guardian. It's a hybrid solution which transforms the Calgary road conditions map into a powerful quantum-powered Google Maps type application. And yes, we made like a small beta during the 48 hours that we had. So let's go through a demo. Imagine you're the car driver. You want to get to your work safely. Now you can see which roads have been cleared in real time, as well as be able to report certain lanes which haven't been cleared, which might be a shortcut to your work route. And all of this dynamically feeds into a central database which would optimize the route then to able to change the routes for the snowplower to make sure all streets of Calgary are cleaned. This is what it would look like on the City of Calgary side of things, the planning dashboard, where you can account for construction, you can account for any road congestions, be able to track each snowplow, see how much they have done, be able to contact them to reroute them, as well as take into account priority zones. Certain zones need to get cleared first, and as well as more information like the updating traffic conditions, or let's say an emergency vehicle is stuck in snow and you want to reroute the snowplow for that. Or citizens are reporting certain lanes, as well as the updated weather conditions. So this problem is very hard and complicated. Jamal, how do you think we can solve it?
Yeah, I think we have to do some magics, but there's a fine line between quantum and magic. Trust me, whenever I talk about superposition and entanglement right now, as you can see, my friends think that I'm a magician, but I'm no magician. I'm a quantum physicist, and I'm going to walk through you to the quantum principles here. So in classical situation, we have bits, which is 0 or 1. But in the quantum situation, which is a qubit, we have 0 and 1 at the same time. And let's do the thought experiment here. Let's see we have a cat, and we are going to put that cat in a box with a poison. And if we don't look in the box, we could say cat at the same time is dead and alive. What does that mean is this is the superposition between 0 and 1. That means 0 dead or 1 alive. Exactly. So we are on the both slides at the same time, and that has a probability. And that probability distribution is over all of the presentation, as you can see. And we don't know when does that happen. So that's the entanglement, right? That means two qubits are interconnected to each other, and they are making one object, and that makes 4 possibility outcomes out of it. So that makes it super powerful. Let's think of the entanglement as 2 qubits that are playing seesaw. That means affecting one of them affects the other one. And that is the entanglement. And as I mentioned, these two are making the super powerful quantum computer. And what does that mean is when we are considering like classical situation, we have to like try each of those roads one by one. But in the quantum solution, we have the superposition and entanglement. That means we are trying all of the possible situation at once, and we are finding the solution much faster than the classical counterpart. And that's the power of superposition and entanglement. Let's go to the mathematics here. In a real situation, we have this quantum path that tries the minimum, global minimum much faster because of the quantum tunneling. But in a classical situation, that red ball should go all over the place and find the global minimum one by one. That's heuristic, and that takes time. But in a quantum situation, that takes much faster because of the quantum tunneling. So how we are gonna use these powers of the quantum approach, because quantum is not enough. We have to use the classical computer at the same time, because it turns out hybrid solution is the best solution. Think of quantum processing unit as a GPU, it has to be CPU somewhere. And classical computer is CPU for quantum processing unit. Because we are using that for optimization of the parameters, and the hard part could be delegated to a quantum computer or quantum processing unit. During the hackathon, we tried different optimizers in IBM hardware and different ansatz, and it turns out the best solution is Kobila for the runtime. And the reason why we did that is because we have a realistic configuration. We have to come up with the best option so we can tackle this problem efficiently. It turns out, based on our simulations, if we can simulate 12 nodes with the quantum computer, we can outperform the classical counterpart. And if we look into the history of quantum hardwares, we are seeing that there are a lot of new players coming to the game, like Rigetti, Google, IBM, and D-Wave was there for a long time, 2007. And D-Wave is showing some outperformance and real applications of quantum, as we are going to see. So this field is growing, but how we are going to use this power of quantum and use it right now? It turns out if you use D-Wave and NVIDIA at the same time, we could use GPU, CPU from hyper-performance computers that NVIDIA provides, and GPU from D-Wave, and put them together to give us a real benefit. And it turns out, based on NVIDIA's characteristics of the communication back and forth between GPU and hyper-performance computers, less than 10 seconds it takes that you communicate with the GPU and get the result out of it. So if you want to make a real application, that is realistic in real time. So for going forward, this is the D-Wave's computer. In a recent research, it shows that in the vehicle optimization road problem, they tried different CPU for like normal computer approach of solving it, or QPU from D-Wave and hybrid approach. It turns out for the small size of the problem and the medium size of the problem, like hybrid approach is outperforming or having the same result comparable to the classical scenario. And that's not only it. This is from the previous D-Wave's hardware. This is the newest topology from D-Wave that has much more entanglement between qubits, and based on topology is much better than the previous topologies. What does that mean is, if we see these results from the previous research, we are seeing that always the hybrid approach is much better than the classical approach or comparable. Well, let's imagine what would happen next. This is gonna come like in 1 or 2 years, because D-Wave showed this topology in 2021. So it's gonna be released soon. And that's why we can do quantum right now, because we can do fast optimization in less time and less fuel consumption, which is aligned with the city goals. So classical computers brought us here so far, and we are so grateful, but that's not enough, because classical computers based on Moore's law are seeing a Plato, sorry, not philosopher, the other one. But the quantum computer can outperform these classical counterparts. And today is the opportunity to invest in quantum and see the benefits for the future.
Okay, that was a lot of quantum stuff and graphs, and I'm a software engineer. It went all over my head, kind of. I hope you guys are still awake and with me. So like Jamal said, the classical computers have done whatever they can, and now the transistors are so small that we are entering the quantum realm, so it's time to start thinking quantum now, because in the next few years we will be ready. And then now, let's slice the elephant, because I want to show you how we can solve this problem today. And don't worry, no animals were harmed in the making of this presentation. I know we used a cat and an elephant, but everybody is safe. And the way we want to solve the snowplowing problem now is by subsectioning the city. We can use a divide and conquer approach. That means that we don't need to solve for the entire city right now. If we can solve for certain subsections, we can stitch together the map to get here in the next 3 to 5 years. Quantum will be powerful to solve the entire city in one go. But right now, what we're suggesting is a hybrid approach which uses classical and quantum computing. Let's see how we can get there with a realistic roadmap. So we had this amazing hackathon, and in 48 hours, we built a very great solution. So what's next? If we start doing research now and collaborate with the key stakeholders of the city, we can have the first prototype complete in the next 3 months. This means we'll have a quantum model which is ready to solve smaller problems with the current DWare hardware that is available right now, as well as work on the application side of things to get the snowplow operator app ready, as well as the planning dashboard. Perfect. So, and this, with starting research now, we'll be ready to pilot something in the winter of 2025, maybe not for the whole city of Calgary, but at least downtown Calgary, so that we can optimize the routes for the snowplowers daily, as well as enable real-time tracking of the road conditions, as well as the snowplow locations. And while doing this pilot test, we'll be able to gather critical feedback from the users, as well as the city, to improve it in our next phase, where we'll integrate the feedback and optimize it. And the best part is that this snowplowing solution not only applies for snowplowers in winters, it can also apply for Calgary street sweeping, which happens in the summer. And this application can be applied to different industries as well, like garbage, delivery, agriculture. All of these use vehicle route optimization. So once we solve this problem for one problem, where we can actually expand it and solve it for the entire industry. So for the past 20 minutes, we've been trying to convince you guys that quantum is amazing, but maybe hearing it in the words of someone who's your own will help you. And David says that our world is a big quantum machine, and what will we uncover if we actually rebuild it using the quantum laws and the power of quantum? I would like to thank the City of Calgary and Kai Ventures to host this amazing hackathon that gave us this real-world scenario to work on, as well as having the city improve our product within 48 hours, and this opportunity to share our solutions with all of you. And I just want you guys to imagine, we met on the day of the hackathon, 5 people, 2 of us are in different countries right now, 3 of us are here, and we met on the day of the hackathon. Within 48 hours, this is all that we came up with. Imagine with the real resources, like enough resources and time, what we can achieve. Because quantum future is not that far. That's why City of Calgary, let us start your quantum journey. Thank you so much.
Okay, so I do want to open up for questions, but so what's next? What's next for you?
I mean, you can see the roadmap, right? We can start right now and do the R&D and keep things going, because right now D-Wave has a lot of open source documents that people have worked with these type of algorithms and came up with real solutions. So we could bring all of them together and customize for this problem.
Okay, but the U of C is big for spin-offs, right? Like they help spin up startups. Some of you are U of C involved. How did you guys get involved in the Quantum City then?
So I was working as an intern in QTI, Quantized Technology Incorporation, in Quantum City. And after this, like in a month, after I'm graduating from University of Victoria, I'm going back there as a full-time employer. But other people...
So I don't know that much about quantum. The hackathon was my first introduction to quantum. I'm a machine learning engineer and a software engineer. I'm currently building another startup in Canada. I just graduated like a few months ago.
I have a bachelor's degree in computing science and 3 years of software development experience. I have been exposed to quantum computing concepts before, but this quantum computing hackathon was my first hands-on exposure, and I was actually quite interested in it.
So will you be taking this, is this a startup idea that you're going to take to platform, or what's next?
I think that's what we're here for as well, to see if David would be interested in us.
Yep.
Let's ask the audience. Who here thinks that this would be something worth pursuing?
Woo!
I call that a resounding yes.
Good stuff. Okay, I did have one more technical question, though. Okay, so when you were running your tests, where did you get the compute power to do that? Like, you weren't using computers, right? Were you using cloud, and how did you get the compute power to run your tests?
So for those IBM tests that we have done, those were provided by Sandbox, like the company in, is it in Mexico? Yeah, QCentroid. Yeah, Spain. Okay. Those are these that are from like using cloud. And for DVA ones, those are just papers that showed these results. And for DVA, yes, there are some cloud access, like open source access to the cloud of DVAVE that you have to purchase, but I had like 1 minute free access, so I played with it. So 1 minute is a lot, trust me. Like I used like 3% of 1 minute. And if you want to like do something like this, you can do it in 1 minute.
Okay, we need to play with this. And Dave, you know, one of the things that we've done here is, you know, we have standard IT equipment and standard software, and one of the things that Dave, you really championed is having our own network, but then having access to a local cloud company, even just to do our own AI, right? So we're using Denver data.
Works for AI.
Yeah.
But if these cloud compute for quantum is available, we can connect there as well.
Great.
So.
Any questions from the audience? Okay. Thank you all very much, and hope you can hang around for a bit, and we'll give you a bit of a tour.
All right, good afternoon, everyone. My name is Nan. I'm the IT manager for the emerging technology. And I hope you have a fun Friday afternoon here. And I was here this morning, all those presentations blew me away. It's like, I need to go back to school. And here, that's why I invite Professor Lone from U of C. So what he's going to talk about with us is that we call the YYCRobot project. I want to give you a little bit of ideas about, so a couple years ago, I think Jan and we have sort of an idea that maybe the next generation of AI and how robots could be used as cities is something that we should explore. For example, probably robots, lawnmower, right? I think we already tried with our recreation parks. And also robots for, how about -40, we have robots just outside clearing our snows and everything. And also, like, how about robots basically helping us clean up C-train platforms and pick up the garbage, etc. Right? Some of these simple ideas, which make us think that from IT, we think maybe we should have better understanding about how robot works. So the idea is that yes, we can spend probably some dollars and buy a robot, put it here, but how about we just do something, crack open the box and build something made in Calgary. And that's where that robot's coming from, the idea is, let's try it from scratch. In order to do that, basically give us an understanding that how exactly a robot works. And it's more important that if the robot pretty soon is that, say, now on our streets, our parks, how City of Calgary can securely manage those robots. What about cybersecurity? Do we have a management platform? How do we make sure they're not going everywhere? I was just playing with our robot here, and the students and researchers told me that they intentionally slow it down, crack it down to speed, because it could be like a racing car here, and it could hit into any of you, right? If it goes anything wrong. So that's basically to tell a story that there are some security measurements that we really need to understand and really want to put in place. And now we learned a lot through this process with U of C, with Henry's group. And we also want to share that Henry's group, I think there are 2 other researchers here, There are multiple PhDs behind these things, and it's still difficult to figure out some of the parts, right? It's really complicated, and there's lots of learnings going on, and we really enjoy those journeys. So I'll let Henry share the details and how the project, right?
Well, thank you.
Go ahead.
Can you hear me? Thank you. Thank you, Nan, for introduction. And thank you for City for giving us this chance to present our work on this YYCRobot project. So we were approached by the City IT group. They suggest, can we design a robot to be used in the City Hall as a reception? So that's project one. Yeah. So originally, I thought that we thought maybe we can buy one. A lot of time we just buy one, but City said they want to have one built by Calgarian. Okay, so it's totally designed and built by Calgary people. And there are certain functions originally we want to have. Okay, so first is the robots able to greet the visitor to the city, and also ask about what's the nature to the visit to the City Hall. Okay, so they can tell the city employee about services requested by the visitor. Okay, so that means the robots should have capability for verbal communications, talk to people, respond to people questions. Okay, we're able to send messages to the visitor about some available service. Okay, you can tell them, okay, you can do that, different type of functions. Okay, what the robot, we're also able to lead the visitor to different locations. For example, some visitor may come to, I come here for certain meeting. Okay, the robot can, that's the way, can guide them to lead them to that locations. Okay, so also maybe they can give some safety instruction or directions around the facility if needed, okay, if people ask about that. And also if the requirement, the location of any necessary safety gear, okay. So these are all the requirements originally suggested by City IT department to design such a robot. Okay. But we went through a long process in this collaborations. So we put the information in this way. We start from the IT group, okay? So they have, they want to develop more advanced technology. You can use the technology, combine robot, IoT. And then they also hope the robots should be fully autonomous. Can interact with human. But after that, okay, we also discuss with the corporate security group. Then they have different expectations. They also want the robot can able to achieve. So the robot should be able to alert the staff, provide opportunities to gather evidence for incident reporting. Something happens, okay, the robot can go there, take a look, report to them. Potential to integrate with the control center, okay, because they show us they have a control center in the city. So the information can send to the control center, more like a defense application. This robot can go around more surveillance. And then the IT group also bring us to talk to the facility management group, okay? So the robot, they also have a different view of the requirement of the robot. The robot should be able to guide the visitor to appropriate destination within the municipal building. Okay, so this is added by the facility manager. Finally, we also talk to the advisory committee on accessibility. So they are more concerned about how about people. They have difficulty, hard to hear, loss of sight, maybe some difficulty with speech. Okay, so they also hope the robot have this capability, can communicate with people with different types of needs. So we combine all this requirement and start to build the robot, okay? So this is, the robot will be eventually. So the owner, of course, is City of Calgary, okay, in the IT group, also the corporate security, facility management. The people, they will interact, or we call the customer, would be, of course, the citizens of Calgary, also the corporate security, the City Hall reception group. And they can also, this robot, okay, we also think can have influence the industry, like Platform Calgary, Design Focus Group, Calgary Economic Development, and some local robot industry or academic. They may be interested in that. So this is some background about this project. Where do we come from? Okay, how do we come up with all this requirement to design such a robot? Yeah, is to have IT is to have a Calgary-built robot, humanoid robot. Okay, so let's talk about the team. Okay, the people involved in this project. So because this is done by Calgary people, right? So they found us, University of Calgary. So myself, I'm a professor at the university at the Department of Electrical and Software Engineering. Okay? So the work would involve different people. Gayan was my PhD student. He graduated now, working in the local industry. He's the main developer. Okay, he takes care of the mechanical parts, most of them. So he is here. Okay, King is a PhD student. Okay, so he's doing more on the AI part. Okay, so his expertise is artificial intelligence. So we have Anil. He was a postdoc fellow, but he left. He went back to India as a professor now. So he also involved in speech processing. Okay, and we also have Johannes. He was a visiting student from Germany. Okay, so he helped us to design certain part of the robot. Now he went back to German and working at the local industry in German. So he is quite international. Okay, but we think, the robot, because we said it's from Calgary, it's not only from University of Calgary. So after discussing with the city, we think, we should involve more students. Okay, so we find some high school students to participate as well. Okay, so this is another team. We got our high school team. Okay, so we find different high school, okay, to be more distributed. So we find a private high school, Web Academy, UNES. Okay, so because the project has been 2 years, so when they join, it's grade 11. Now they all graduate. So now she is at Johns Hopkins University doing biomolecular engineering. We have Mayuri. Okay, she was with charter school, not private. Now it's charter. It's Westmount Charter School. She also graduated, and now is a first-year computer engineer at Waterloo. And we have Aliyah. Okay, so she was with the public school, Western. Okay, now it's a first-year computer science at U of T. And Bernice used to be in Sir Winston Churchill Public School, and now it's at UBC in engineering. So we think we have more distributed, more diverse involvement to design such a we call YYCRobot. Okay, and of course, very important, we have the city team. Okay, so you can see a long list of city people we have been talking to. They all give their opinions, suggestions, help us to solve the problems. So we have the IT group, lots of them. We have Nan, okay. We also have Ashik, Colin, Maisa, Suzanne, Haprin, Singh. But I think we miss James. James helped us to suggest somehow to print the body, okay. Yeah. So we have corporate security. We talked to Keith, Alex, Surgeon, Vijay, facility management. We have Alvin, Dennis, and then advisory committee of accessibility, Leanne, and Renault. Unfortunately, I cannot find all the picture from the public domain, so I can only put their name there. Okay, so doesn't mean they are less important, but just very hard to get the picture. Yeah. Oh, that's okay. So this is the team with 3 groups, a lot of different academic, university, high school. We try to find some elementary, but I think it's too difficult to work to ask them to do, yeah, they may play with the robot. Yeah, hard to build, okay? Yep. Then let's look at the robot design. Okay, so basically in our robot design, we have 3 major components, okay? First is the mechanical design. So that means the whole body, okay? So the whole humanoid robot, okay, from the head to the body, okay? So we look at the mobile base, okay? Because after discussion, we think it's too much, the cost is too high to build robot with legs, okay? So we just have a mobile base. The arms, so we hope the robot can shake hand to people, give some guidance using the hand, or those not doing heavy job, okay? And then the head, okay? And then of course, because this is robot, right, we should have some AI, artificial intelligence capability, okay? So we expect the robot can do object detection, find out where's the target, where's the obstacle you can avoid, 3D perception, because you have to move in the 3D environment, okay? Speech, because we mentioned the key function of this robot is to talking to visitor to the city hall. Yeah, sorry, I double play, okay? It's a mistake, okay? And then finally, right, we have to have a good body design. Make it humanoid, okay? It's very important part, right? Whether citizens like to talk to this robot is the appearance. Okay, we don't want them to feel afraid of the robot. They will feel this is friendly. They like to talk to him. So we have been thinking about should it be more cartoon style, very real human style. Yeah, we discussed a lot. The skin materials and then the color to have this final design. Okay, so let's look at that one by one. Okay, so the mechanical design is also based on a lot of discussion with the city. So we come up, this is the acceptable freedom, flexibility, the robot we should have. So they expect the hand can move, 5 degrees of freedom. Okay, so the hand can do something, shake hand, pointing to directions. Okay, the head, they want to have eyes, so they found it's good to have the eyes on the head. Okay, the eyes should be able to rotate a little bit, more like human. They thought that we will feel more comfortable to the visitor. The head's able to rotate a little bit. Okay, and then instead of legs, we have a base. Okay, yeah. So this is kind of the mechanical design requirement, and then the robot function at the end. Okay, so first we will design using computer aided design. We'll design the base, the chassis. Okay, this is the base with the kind of the main body. Then we will put the arms and the head to the robot. So now we are designing the head. Okay, so that's the location for the eyes. But this is the design. And then after we do the design, then we will build it. Okay, so this is the built one for the chassis, and this is over there. Okay, so it can move. So can you? Yeah. Let's take a look at the base. Yeah, so it's important. We have to make sure when we discuss with the city, right? We don't want the robot is too noisy. We don't want the people scared. It has to be very quiet, stable, smooth. So when we talk to people or guiding people to different locations in the municipal building, they feel comfortable. So this is a lot of criteria. We have to make sure they run in this way. Yeah. Yeah. Okay, so you'll feel free to take a look after this. I think you can use it. I think then just put a coffee on the top, and they can bring the coffee to him. Yeah. Well, then we look at the, this is the mechanical design. The next part is the AI, okay? So this is something we put more research, more novel stuff, right? This innovation, right? So we have to do some 3D perception, okay? We only have camera, so we need to use some AI to generate the 3D environment, okay? So this is generative AI. So we can create a 3D environment from camera, so the robot can smoothly navigate in that conditions. Yeah. The video is too long. I think we can just stop here. Oh. Well, as you mentioned, right now, besides you can move, we expect to be like human, right? So you can detect objects. Okay, so we already designed the robot. Okay, we have very reliable detector, already trained it, ready to put on the robot. So you can detect human. Okay, we can also use it, go by to count how many humans. Yeah, if the city need that, they can also use to select, to find some missing person, as long as you can give them the picture of that person. Okay, yeah, the other function, not only human, the eyes can also find objects. So if some visitor, they say, oh, I forgot my cell phone, I lost my jacket, then you just tell them, then they can help us go around to search for different types of missing objects. And then you can send it back to the reception group office or security. Yeah, so this is one function we'd like to have in this robot. Okay, and the next part, right, except the eyes, except the motion, we also expect one importance, the AI need to talk to people. So the robot can communicate, continue communications to explain responses from context for each individual. So you need to be able to answer different types of questions, not only one answer, maybe continuous if that person keep asking, you need to keep responding, okay? It's quite difficult sometimes because they also talk about how many lots of people talking. Okay, so we also need to prepare to handle those situations. Okay, so the setup should be completely offline. Now, this is the requirement from City, because without maybe we can connect to the internet. But they don't want to have that. They said they want to be isolated. They don't want to connect to any central. They don't want to record any citizen voice for security purpose. So they want everything local in that robot. Okay, so that's causing quite a bit of work to get it done. Potential, they want to have multilingual support. Okay, if people have different language, they can also translate and explain that to that person. Okay, now so this part we have difficulty. When we first start, we're developing a speech recognition systems. But in the middle of that, then we have ChatGPT. Oh, that makes things completely change. Okay, so all the thing we did before is not compatible with ChatGPT, so have to switch. We also have to switch to using the large language model, okay? But then the challenge is the large language model is pretty large, right? So it is usually run in the cloud, okay? But then we have to, because of the second requirement, we have to put it in the local computer. Everything is local computer. We have to train using our data. You have to train using some of the questions City would like to have. Yeah, and that part is almost done, is kind of done. Okay, so we have to select fine-tuning, filtering procedures to reduce any possible false information response. Okay, so we haven't put that on the robot yet, but we can only show some examples.
Are there any libraries close to City Hall?
Yeah, so we only display, so it's easier to see. So that's a little bit time because you have to display the text. The response is pretty quick, okay, you can see, yeah.
Okay, how do I get there?
We haven't selected the voice. We need to ask City which voice they want to use to represent it. It's not our voice, so City select is a male, female, who.
So how many minutes away is this?
Yeah, so we only display. Now we can do that, but we need to find a voice to represent this is the YYC. Okay, yeah,
so you're saying if I cross the crosswalk, I can get to the library?
Yeah, so we just, a little bit slow because we display the text, okay?
Right,
so this
thank you, bye.
Okay, so that shows the response. Well, the last part is the body design. So you can see this is designed by the high school team, even the presentation, they look different. Okay, they are younger. Okay, so that's what they search for different types of robot. Okay, which one is more friendly? I think they more tend to be more cartoon style. Okay, so they look for different types already in the market, in the business. So I think that's what they start from. And then they start sketching based on the requirements City would like to see. More friendly, humanoid type, but not too human. So they have different sketch of different types of robots. Okay, and then this is the final sketch, the final design. Okay, may not be very clear. This is roughly with the condition. We want the height. Okay, so we also discuss about the height. We don't want them to look like a kid. People may not believe a kid. We don't want to be too tall. So this is the height we design. So we give the condition to the high school team, so they will build that. So they would think this should be more human-like build. They think should be cartoon-like face with simple design. We don't know why, but they said this is good to be more blocky, okay? Yeah, so I think maybe this younger group like to see that. Okay, so then they use their software, yep.
The high school students designs that because we don't want to make it look like human, like too scary.
Okay. Yeah, I see. Yeah, so then they use the computer software to draw the design. So that would be the robot looks like eventually. You will see in City Hall someday. Yeah, it would be like this. Okay, the base is like that. Okay, so this is the wheel, this is the body, that's the hand, and this is the face. Okay. And they have some suggestions, the team. They want to have, on the base, they would like to put a painting like that to highlight this belongs to Calgary. Well, because they're all born in Calgary, right? So they want to highlight aspects and buildings that make Calgary unique by incorporating a modern art form. Okay, so that with the, I think this is Calgary Tower. I don't know which one is. I think this is the Peace Bridge. I don't know, that may be the Rocky Mountain. Okay, I don't know what is that. Okay, but anyways, they thought this picture represent in the base to show this is from the YYC, from Calgary. And they also want to have a sticker design. They suggest on the helmet, they want to incorporate some hand-designed sticker to put on the hat to represent, this is our design, that totally designed by Calgary, led by City of Calgary object. So we haven't designed that, or we wait for the city, maybe let the city to choose what they want to put the sticker on the hat, on the helmet of the robot. So maybe flames, maybe some Alberta national flower, maple leaf from Canada. It's up to the city group to choose, then we will try to put it there. Okay, so that's cover the YYC robot projects. Thank you. Any questions?
Yeah. It's moving now because originally we programmed this robot for City Hall. So when it's powered up, it's actually trying to scan the environment. So you put a robot into a new environment, it's scared, it's shy, right? trying to find out what's the environment, where's the wayfinding. So now once it's scanned, it starts moving, right? So that's what it took a little bit more time. Again, this is all learning. I didn't know this until today. So
Thank you. Any questions?
How did the project come about? How did the city and the U of C connect on this?
We have some background. We have been doing quite a bit of robot projects. So I think city contact us.
This is through the Urban Lines. Urban Lines, sorry, I forgot.
Yeah,
the UFC Urban Lines project, yeah. We've been doing lots of research project with UFC. And then when we have this robot idea, say, hey, how about we try this, right? So yeah, it started from a research project and then basically say, maybe we should try also build something more than a paper or research paper. That's how it came up, right? Yeah. You can see there are lots of learning, right? Like even today, and I think Gayan and King was going to demonstrate the voice pieces as well, but it's not working as we expected at this environment, right? So there are lots of tuning and lots of learning pieces too. It's not as easy as we thought, that just buying, but
well, because we need to make sure it's very safe, right? We don't want to hit any people, cause any accidents.
Go ahead.
Yeah.
And Urban Lines has been in place since 2007, and the city and the university have worked on over 400 projects together. So this is just one example.
That's awesome. 400 projects. That's awesome. Yeah. And I was just always like when Henry mentioned that. 2 years ago, I think when we started this, is like, yeah, we built model. I still remember, I think it's one of our students training the large language model or natural language model, but all of a sudden like LLM, ChatGPT, and then now this Meta open source large language model is like, oh, right? That's so funny that all these technology evolves so quickly. Yeah.
I think it's easy to see how this could transition from doing tours for the public, but by being to that assistant even in a place like this or at transit, right? If you took all the user manuals for all the equipment in this room or all the user manuals on a Detroit engine in a bus, and so I could be the mechanic working on the bus and say, oh, how do I change the oil in this engine, right? And Jarvis could pull that up and show me a video on her face, and right? I think that'd be really neat to have that personal assistant that can retain all the information on how to run our speaker system, right?
Well, even look at, to your point, like Jason, look at, for example, I'm thinking in our community center, when people, new immigrants, people doesn't understand English, come in, could talk to this guy. Oh, by the way, we need a name for this robots. So more than welcome to come up with some names. So and talk to this and get the translation going on, right? So.
I think CSNC would like to run a naming competition, right?
Yeah. Jan was comment that CSNC would like to run a naming competition, naming hackathon, right? It's now
Exactly. We'll go to all the schools.
Yes,
Get
yes.
the elementary schools involved that way.
That's for sure, yeah.
Thank you so much for your presentation. I'm Vanessa from Bow Valley College Applied Research. My question is actually just talking about, this is a kind of first test use case. If you're thinking about rolling out this out wider, how much does a robot like this cost?
Oh,
the background side of it. Yeah.
We try to make it very low cost because it's government money. We don't want to waste it. Yeah. So, but manpower to develop it takes lots of energy. Okay.
Yeah.
But after we have all the design to replicate, of course, will be way cheaper then.
Yeah.
Yeah. Cheaper than the Pepper robot.
Yeah.
I talked to Bow Valley, right?
Yeah.
They are trying to purchase a Pepper robot, right? I think. Yeah.
Yeah. And we have been reviewing lots of these procurement costs and keep mindful of that. Basically, so this robots, if just from the hardware perspective, is really, really low cost. But as Henry pointed out, it's basically with these 3 or 4 PhDs, labors and times and efforts. But having said that, that's basically the one time you've done this, then basically it's a little bit, I wouldn't say cookie cutter, but it's much better and quicker to build the second and third one, right? It's like build an army versus that build the first one. So, yeah.
Thank you. Okay. Okay, thank you.
Okay, we're going to get started. We've got Greg Hart from Inception U and just about everything else that's going on in the city. And really just talking about, you don't have to be a deep, long-standing university or institution here in the city to be making some big waves. All right, and with that, I will pass it off to Greg, and I'm going to get you, there's a water for you right there as well.
Thank you. Thanks, Jason. Great to be here, and for the people online. And I was just telling Jason, I've been traveling so much lately, it's sort of weird to be in Calgary. But I'm happy to be here, and boy, does this look different than the last time I was in here. This looks really super awesome, so I'm thrilled to see this come together. And actually, I'm going to start off by saying that I'm going to tell you a bit about Inception, but I'm going to start off by saying that Inception has been working with the City of Calgary and City of Calgary data for a long time. So in every full stack software development course that we run, we have 3 projects that everybody participates in because everything that we do is project based. And the second project that we use city data. So we basically challenge teams in our program to take a look at the city data that's available and then decide, what's a challenge you'd like to work on with that data and see if you can develop a tool as part of their ability to both think as designers, but then also pull together their skills as full stack software developers. So that's something that we've been doing for a long time, and it's awesome. So we have those projects are underway right now, and we can make sure that when they're done, and then we'll invite you to demo day, and you can come and see how these projects turn out. So that gives you a little bit of a preview into Inception, and I'm just going to give you a little bit of background. And you see the title here is "Experiments Are the Root of Learning." And I think because we've learned so many things and we've been able to put it in books, that we forget the fact that the way that those things were learned was by people running experiments. Like everything that we figured out in the world, we figured out by experimenting in some way, some form of trial and error. But one of the things that we see when we bring people into our program is they're hesitant to start doing things. They always say to us, "Hey, Greg, can you just make sure I know everything before I start?" And I'm like, "No, that's not going to happen. I'm going to give you things to do which you're not going to be able to know how to do, and you need to try and do those things." Because that's the first step, is to do a bit of trial and error, get comfortable with the fact that you don't know how to do everything, and then just get doing it. But we've kind of built a culture where you had to pass tests, you had to get certifications, you had to do all these things, and the message from all of that is you're not ready. And so the question that we ask at inception is, are you ready? And the answer to that question needs to be yes. And that means you need to be willing to start stuff before you know all the answers, because it's kind of boring to start things that you all know all the answers to. So everything that we know in this world, somebody figured out through a trial and error process, because that's actually how humans learn. So that's a core idea that we use at inception. And the origin of inception was there were a real struggle in Calgary to find people with the right mindsets to fill jobs in the tech industry and in the innovation industry in general. And we went, and the idea wasn't to start Inception new. We actually went to the existing institutions and said, hey, there's some things we need to adjust in order to make this happen. And the answer was probably not going to happen. Probably not going to happen quickly. So if finally somebody said to me, if you think this is such a big problem, you should go and do it yourself. So being a lifelong entrepreneur, I said, okay, challenge accepted. So I'm going to show you a little bit about more about what we think when we look at this stuff. First of all, this is a word that we hear a lot, which is interesting. Oh.
That's our, this is, everybody else in the audience has used this already. We had this with another.
Oh, okay, okay.
We could try a screen share. Like, can you cast your, like an Apple device?
Oh, like a.
Yeah, let's see.
Let's click share. I don't see a screen share casting option, unless maybe I have to be on the Wi-Fi to do that. Well, let me just see what happens. Let's see if we can. Yeah. Is it going to do it on every slide or just every occasional slide?
Yep, we'll see.
Okay, it's not moving right now. We're good. We're good. We'll figure it out, because this is about agility. So the thing about Agile is, I like to actually say that Agile is the most popular, least understood concept in business, because everybody's like, yeah, we're Agile. So a company once was changing direction all the time, and I said to the CEO, what's going on there? We're being Agile. I'm like, I don't think you know what that means. I mean, the idea with agility is you're moving quickly with meaning, right? You understand where you're trying to go. You're running experiments. You're trying to understand what the risks are. You're trying to reduce the risks. You're trying to do things that value people, and you're trying to do it in that kind of way quickly. So this is a core concept that lives at inception. So let's see what happens. So here's the other thing. When you don't know what's going to happen in the future, you can't use a map. You need to use a compass. So that's another thing that the approach that we take, again, because you don't really know where you're going, then you can't take a map to go there. And I have an example which won't work, but this is Vancouver Island. So if you were in Nanaimo, which is where I just was, and you want to get to Tofino, now there's a map, so you know how to get there. But if you click the next picture, you see what it looks like today, because there's a map that's exploiting what we already know. So there's a road there, you can follow it. But before that road was there, this is what you saw. So if you still want to get there, you're not getting there with a map. You're getting there by trial and error, finding your way. Oh, we're going to go this way for a while. Oh, no, that doesn't work that way. Okay, so we're going to go this way for a while. Oh, it doesn't work. Until finally you find your way to where you need to go. And I don't think this is actually on the way to Tofino, but it's on Vancouver Island. But anyway, the point of it is you always try to run the smallest experiment that you can that costs you the least resources and the least effort to find out the next thing that you need to know. And this is a core idea behind Inception and how it goes. Keep going. There we go. So the Agile Manifesto is a document that was created in the 90s, but it captures these very important ideas, and I'm going to tell you why in a second. But the 4 core ideas inside this are individuals and interactions are more important than processes and tools. It doesn't say processes and tools are not important. It says that individuals and interactions are more important than those things. Working software is more important than comprehensive documentation. So the best way to test how well what we're doing is working is to actually build stuff that works. If we want to know how things are going, let's build something that works and use that. And that's the way, this is a core part of this. We're not going to talk about what we're going to do. We're not going to write documents about how great it's going to be. We're actually going to build it and show it to each other. Customer collaboration over contract negotiation. So many things happen in the world where it's like, I hire you to do something for me. You go away, you do that thing, you bring it back to me, and I sit there and go, yeah, that's about what I wanted, but there's these other things I really think you could do a better job. Go back and fix it. In Agile, the idea when it's done really well is that we actually take the customer and make them part of the team so that what we're actually working on is trying to solve the customer's problem together. So in other words, the customer isn't bringing me a problem that I solve on their behalf. They're joining the team, and us together are working against the problem. So it's not like I'm trying to show the customer that we're doing the right thing. The customer's on our team. What we're trying to show is the problem, that we're doing the right thing, that we're actually fixing it. And this is a nuance that does not often get caught, but it's part of the experience at inception where we talk about this kind of idea. And then the final one there is responding to change instead of following a plan. It's not a terrible idea to work on making a bit of a plan. But if the plan dictates what you do, then you can't respond to change. And if you can't do that, then you're dead in the water today. Because responding to change is the core idea of working in the future. Let's see what's next. You can escape out and then... Yeah, the point being here that you can do that with anything, right? So what does it take to be future fit? Well, there are 8 things that we look at, and the first one is a designer. Everything outside of nature was designed. Everything in here, except for the humans, was designed, unless there's other animals in here too. Well, pet-friendly. Pet-friendly. So if there are pets in here, then, well, yeah, they're still not really designed, although we have had a hand in breeding some of those pets. But basically, everything else in the world is designed. So that means design's kind of important. And that's a key part of the work that we do at Inception. And we look at it as being creating the conditions for success. That's all design is. It's understanding what the win looks like and then creating the conditions to get there. That's design. It's yes, how it looks, yes, how it feels, how it works, all that stuff. But the core idea is you need to know what it is to win and know what the conditions are to create that win. Second thing you have to do at Inception is be a fan of reality. Now this seems like a pretty straightforward idea. Of course you should be a fan of reality. I don't know if you notice, but humans are not doing really great at this these days. I mean, it's hard to find evidence of this problem, but you know, if you flip open any one of your social media apps, I'm willing to bet the first page is going to show you this. And this means you have to have an unflinching commitment to what's really going on at all times. So to build great products, you need to do this. But to be a great human and to be a great citizen, you need to be able to do this too. And this is a core part of the Inception model. We push this all the time, that you need to be evaluating reality. And the reason for this is any organism, any living thing is only going to do well to the extent it really understands the environment it's operating in. Because if you imagine things to be true that aren't true, and you respond to imagined things to be true, that's not going to actually help in reality, because you're responding to something that's not real. And there's a lot of that goes on, and we can see that it leads to generally not very great outcomes. So you have to be a reality fan. Adaptive. So this is this part about responding to change. Need to be able to respond to change. So this is core. In the Inception program, we work on this ability to be adaptive, to always be able to adjust to the things that you're learning and flex with the changing conditions. And then you need to be comb-shaped. Has anybody ever heard this before? Does anybody want to be shaped like a comb? So the idea behind comb-shaped is used to be this idea of a T-shaped person. So the T is, the horizontal part of the T is just sort of your your breadth, your synergistic knowledge across disciplines. The vertical part is your discipline-specific knowledge. So if you're a software developer, for instance, it could be even very specific, like you're a front-end software developer. And if you have no other connections to anything else, like you don't think in the design terms, you don't think about back-end work or whatever else, then you have no horizontal part of your T. You're just an I. And there are a lot of I's out there in the world. The T-shaped person was the one who was like, okay, we're adding this horizontal component so we can see how things connect together. Even the full stack developer as an idea is essentially a T-shaped idea because it's the whole stack of software development. So comb-shaped goes one step further, which is to say you're going to have this really thick synergistic piece that goes across horizontally, and we're going to develop a bunch of discipline strengths that are connected to each other. Comb-shaped people who are adaptive are going to be very successful in the future. Is that bad news?
I just said I was pear-shaped.
Oh, yeah, pear-shaped. Don't worry, Jason, pear-shaped people will also be very successful in the future. Networked, so this means connected to information and to people. And this is a core thing as well. We're a social species. We only actually succeed if we do well with other people. Don't tell Elon Musk that, but it's true. And so this is a key part of our work as well. Next one. Learner. This seems kind of obvious. We don't say student. We say learner. Because the idea here is you're continually acquiring and updating your knowledge and your competence. Inception U is a competence-driven program. So there's no tests of knowledge at Inception U. Because I referee lacrosse, and I'm actually in charge of all the lacrosse officials in the world. And I can tell you that I know a number of referees in lacrosse who get 100% on their knowledge test. They know everything. They know every rule. They can quote to you the number from the book of each of those rules. But then I put them on the floor and have them referee a lacrosse game, and they're kind of a catastrophe. And yet it's like, whoa, they're fully certified. They passed the knowledge exam. They did a great job. But that's not what it's about. The conversion of that knowledge into ability is competency. Know-how is the key thing. And so everything that we do when we talk about being a learner is about acquiring competency. Anti-fragile. I don't know if you're familiar with this idea, but essentially this is helping people acquire the ability to actually get stronger as you get surprised, as you get a punch, as you get anything. It actually makes you stronger. So this is an ability to respond to the world in a way that makes you stronger even when there's friction and difficulty. And last is intentional. So we have a statement that we use, which is be meaningful, not mechanical. Life is not a series of checkboxes. If you want to create great technology, it's not a bunch of just mechanical steps one after the other. It's understanding in every step the thing that you decided was the success you needed to achieve in the first place, and then taking each step to understand how that's connecting to that thing. Because the moment you start writing code or wiring something together and you've forgotten what it was that you're trying to make successful in the world, your product is going to start to go like this. And this happens a lot. This is the one thing that I would say explains more crappy software and technology than any other single thing, is this lack of intentionality, this lack of connection to what it is that we were trying to do in the first place, including being adaptive enough to realize that the thing that we wanted to do in the first place is no longer a very good idea and we should just walk away. Because that's a really worthwhile step to take as well. And there's lots of products where it would have been great if people had walked away instead of forcing them into the market. So this is what we call future fitness. It's not being future proof, it's being future fit, right? So that's the key thing. Future proof is like having a shield or a suit of armor to protect you from the future. I don't recommend that. Being future fit is having the ability to fit into whatever the requirements are and having the capacity, the fitness to be able to meet the demands of those requirements. And we believe that these 8 things are the answer to that, because the future, you might have heard, is described as VUCA. which stands for volatile, uncertain, complex, and ambiguous. Things that humans do not like very much. But here's the thing, it's always been like that. We've just fooled ourselves for a long time because we built lots of nice mechanisms that hide these things from us, but we're now living in that kind of future where it's very, very, very close to us. So that's the essence of Inception U. That's the work that we do. We run programs that are a bunch of different ones, some that are online, some that are in person. Full stack software development is the one that we've worked with City Data on. But we also do full stack design. We have programs in growth marketing and lean sales. And we're actually about to start a program in leadership, which will start in yeah, we're good. I'm not going to do it anymore. Other than, unless you want me to talk about the ants.
I don't know the ants. Tell us the ants.
I'll tell you the ant story. But anyway, yeah, so we're going to start a program in leadership, and then we also have a couple of others that we're bringing on. We're actually even spreading out into, I'm working on a thing with Kate Rayworth, who wrote Donut Economics, and we're doing a 21st century economist program, which we're going to start to offer, I think, later this fall or in the beginning of in January. So we're spreading out. Okay, since the ant thing is up there, I'll tell you about the ants. So ants individually are not super smart. But something happens when you get a whole pile of ants. They become quite a bit smarter as a group. And this is something about complexity. So in that VUCA, V-U-C-A, the C is for complex. Complexity means there are so many relationships that something weird happens when you put all these relationships together, which is to say something emergent happens. So like consciousness. Right now, you're all conscious. Right now, my brain or my consciousness is saying to me, Greg, look at all these crazy things you're saying into the microphone. Where's this coming from? How is this happening right now? I have that consciousness. But that consciousness is not from any one part of my brain. You cannot find something in my fingernail or in my brain or in any of yours that leads to consciousness. So when we talk about emergence, this is something that happens in nature based on so many complex relationships. It just produces these things, and we don't understand the direct connection, and it is ununderstandable. Like, it's not possible to be able to ever draw those lines, which is very different from the sort of mechanistic worldview that we've had, which has produced so much of the technology that we use today. But AI works like the ants. AI, well, at least as it gets bigger, it will. Because if AI gets enough tunable parameters, it will start to act in a complex way, and you will start to see emergent behavior coming from it. Even right now, I mean, it's basically a text prediction engine, but even the way that it works right now, it's showing signs of emergent behavior, which is super cool, super scary to some people, but it's super cool. So back to the ants. So the ants, an individual ant is, you know, not very hopeful. But a whole bunch of ants is good. So down at the bottom corner, we have the ant's hole. And you have to be careful how you say that. Mm-hmm. Yeah, you do. And then up at the top, we have the picnic basket. And that's your picnic basket that the ants are coming to raid. But what happens is the ants all come out of their hole, and they disperse in all sorts of different directions because they're looking for food. When somebody finds food, they start bringing the food back to the hole, and or the nest, however we want to call that. And as they're coming back, they leave a trail of pheromones that other ants, when they happen to wander across it, will notice. And then those ants will pick up that scent, and they're like, oh, that means somebody found food. And so then you get this pattern, which is most of the ants are now going back and forth to the food source. But not all the ants. Because nature plays a game of distribution. It will never send all the ants after this food source because there might be another one. And so other ants continue to just go and look around for stuff, and they don't all follow the pheromone trail. And as you watch a huge mass of ants going through this, it's an incredible thing to watch. I should have a video to show that. But this is something that repeats in nature, and your immune system does the same thing. It's continually sending out scouts looking for particular kinds of bad guys circulating in your blood. And then when it finds one, it starts producing a bunch of other to go and get that bad guy, but it doesn't stop producing things looking for other bad guys. So your immune system works the same way as the ants do. And lots of things, AI is going to work like this. But the message that we take from this story is really that most of your energy should go towards exploiting the thing that you know, but always some of the energy should be going to explore the things that you don't. So that's why I had the picture of the lobby of opportunity there, which is that anytime you're faced a bunch of doors, you can go through a door, and unless you go through the door, you don't know what's on the other side. And all the opportunities that sit down that hallway are invisible to you until you go through the door. So those ants, 20% of them or whatever, are continuing to look for other doors. These ones who've already figured out that this door leads to food are continuing to do that. But it's a behavior that is a tension for any organization or person, because the energy that you use to explore takes away energy that you use to exploit the thing you already know. But you can't learn, and you can't grow, and you can't discover new things if you're not giving some of your energy up to be like the ants who are still out wandering around when they're doing that. So I always say, if you're going to plant a crop, 20% of it should be super weird, because you never know what's going to happen. You got to play. You got to play for the distribution, right? That's how nature works, and we're part of nature, and I think, starting to really realize that again, so we should take advantage. So that's my ant story.
Name tags on Monday, you're going to have to identify as an exploiter or an explorer.
Exactly. Or you could have like a little bar that slides across. Today, I am 75% explorer. Tomorrow, I feel like 75% exploiter.
I am out looking for a Reuben. All right. That's awesome. Okay, so I want to open it up for some questions for Greg, because it's not often that you get to have this time to be around in Calgary and you get to answer questions. But I do want to say, one of the things that impressed me most about your students, there's two things that really impressed me, is that whenever I go and visit your class, you've got 17-year-old kids, and you got 62-year-old real estate agents that are adjusting and finding that love of learning.
Yeah.
And there's that coding piece. So just the diversity of students. And you've got just dropped out of high school to have a master's. I've seen that, like quite a few. Like one class I had, I think there was 2 or 3 people with their masters that were going and doing. How long is a cohort?
6 months full time.
6 months full time. And then the other piece, though, is that it wasn't just about here's the hard skills, especially for engineers. And we talk about reskilling, where they're taught to say no all the time. They're really taught to say yes and even taking that improvisational course. So they're taught to be more flexible, and then they're taught to how to tell a story.
Yeah.
Because how many great ideas fail at not being able to tell a story? So I just want to commend you for that. And if you haven't sat through something with the students there, find an opportunity to. But I'll open it up to questions for Greg. I know it's the end of the day, but I'm sure, I see Kev's got one.
Kevin's not allowed to ask questions. He knows too much.
Yeah.
I am an alumni.
Yes. Oh, really?
Yes.
Okay.
And he's wearing a tie.
He used the 17-year-old in that story.
That's right.
Okay, can you do a very quick overview of donut economics, please? You mentioned that during your presentation.
Oh, sure. Donut economics is, maybe if I have a picture, it will make it better. I might actually have a picture. So I just did this huge presentation on that the donut was part of. So certainly there's my 20% should be weird picture.
Monique, where's that breakdown on our team?
It's pear-shaped, the 20%. The 20% is pear-shaped. Okay, this is donut economics. So this was developed by Kate Rayworth, who's in Oxford. But essentially, it's a pretty elegant concept. So normally we measure economic production by GDP, right? But it doesn't really mean anything, because it's like going to the bank and saying, could you give me 3 inches of money? You wouldn't do that because you don't know what bills are going to end up in that pile. And GDP is like that too. It's just a quantitative measure, and a lot of stuff that's in it is maybe not that related to quality. This one is one that's organized around quality. So basically on the outside of the donut is the ecological ceiling. And these are like thresholds we can't pass if we want to stay alive on this planet, right? The inner part of the donut, the social foundation, are the social components that need to be thresholds that need to be met to keep a safe and secure society functioning. So that means that the economy lives inside this, the delicious part of the donut is the economy. So that's how this model works. So it works like a kind of compass in that sense that you say, these are the thresholds we need to stay above in the social foundations and below on the planetary boundaries so that you can live in the donut. That's the idea behind it. So it's a regenerative framework because our current way of doing economics and everything, you can see the graphs that show these, you know, vertical rises and all of the bad stuff. That's what happens in an extractive economy is eventually it just collapses because it can't be sustained. The idea behind this economy is it's an open economy that will be able to regenerate itself and self-renew, which is another condition for life. If you have to keep adding energy to something, it's not really alive, right? Like it needs the power to be able to recreate itself, which is part of the exploration-exploitation thing as well. And I can just show you that that's kind of what it looks like right now. Red's not good. So in every city it's going to be a little bit different or whatever, but this is the global kind of picture for if you use this as a standard for evaluating. So that's donut economics.
Yes, Alessandro. Yes. Hi, my name is Alessandro, so thank you everybody. So I just want to say that I'm actually right now a student with this amazing organization, and that is an amazing guy over there. Honestly, it's been an amazing experience, and I'm just saying that my process of thinking has changed so much. Like in anything that I see and anything that I do, it's about adaptability and the way you see things. Like especially thinking of humans in anything we do. We have a product, we have to design something, thinking about the human, because everything is about us. You know, when we think about humans, we need to think about ourselves, what we need. It's like we are the final product. Like we need to integrate that thinking in anything we think and we do. And honestly, my way of thinking has changed so much thanks to Inception U and to that. And it's been the best organization. And on this side, I also would like to ask to Greg, how AI will interact more in the education system, and what's your perception of that?
First of all, thanks for saying those nice things. It's great. It's good to hear. And actually, I mean, I would say a common thing that we do hear from people who've been in the program is that they don't see the world the same way anymore after the program. So AI and education. So the educational model, as I said, was built on this idea of somebody gives you a bucket that's empty, and you take the bucket to school and you go to some teachers and you say, please, can you pour some of the stuff that's in your bucket into my bucket? And then every now and then somebody comes along and says, we're going to test what you know, and what we're going to do is ask you to retrieve things from the bucket in order to let us know how you're doing, that's a typical knowledge test. After which people can never find those things again, like they just study to pass the test and then that's it. And so what that means is there's lots of tests and papers that are written kind of in this model. Along comes artificial intelligence, where you basically get to ask artificial intelligence to write that paper or that test for you, because it also has access to the biggest bucket of all, right? So all those factoids and everything else are all available to AI. And so now this has created a crisis in education because the model and how it works has now been completely undercut by artificial intelligence, and it's only going to get worse. And so now you see people running apps that help catch people who are using AI, you know, in their work. And as soon as you see that arms race start to appear, you know the model is done. Like anytime you're in an arms race, you need to know that you're in a bad game. So when you're talking to your young kids and you say it's time for you to go to bed, and the kid says, no, I'm not going to bed. And then you say, oh, yes, you are. You're going to bed. And the kid says, no, I'm not going to go to bed, and then actually stomps downstairs. And then you go down and you escalate, and then they escalate. And then one of the things that I learned when I was a parent of kids that age was that they were willing to go all the way to the nuclear level. And what I learned, not quickly enough, is that that's a bad game to be in. You have to find an exit from that game. And so AI in education right now, I think the message is you have to take an exit from that game if you're education, because it's exposed the basic framework of how we've been doing things. But if we do things, and I'm not saying that Inception has all the answers, but I think it's interesting that AI has no impact on what we do. And so if you're doing project-based learning, which again is back to like trial and error learning, like AI becomes a helpful tool for you now, because it's something where I need to get a kind of an idea. It's like a really super advanced Google search in the sense that it's a find, not a search. So in that way, AI can become a tool that I can use effectively. Or if I'm working with a team of 8 people and we're like just jamming some ideas and trying to figure out what we should do, and somebody's got to be writing all that down, and then we got to figure it out, put that together after, or we let ChatGPT or Claude or even Zoom's AI listen to our conversation, and at the end say, hey, Claude, do you mind just doing a nice summary of everything that happened here? And boom, it puts that stuff all together. That's unbelievable, right? But it's a tool that helps you learn rather than interferes or cheats or whatever. That's the kind of cheating I'm all day for, that cheating, where I don't have to spend 3 hours kind of putting all that together incorrectly. I can just go through what it did and check it for accuracy, and then that's good. And actually, I had this experience with the Zoom AI a couple of weeks ago. I was in some other time zone, and I'm in this call, and we're trying to do something, and I'm struggling to make my point. And I'm making up words. I'm struggling so badly, right? And then somebody says to me on the call, hey, Greg, you could always ask the AI. And I said, ask it what? And they're like, ask it what you're trying to say. And I was like, I could do that. So I asked the Zoom AI, I said, hey, what is Greg Hart trying to say? So the AI goes back over everything I've said and then produces this like 5 bullet point thing. And then, here's the best part, took words that I was using that were not real words, and it put them in quotes and used that to show how I was trying to say something, and then suggested what it was I was trying to say, and it was very accurate. So when I look at stuff like that, that's kind of cool, right? Like that helps you do things and helps you collaborate with people and whatever. So that's like, so AI I don't think is a competitor with education, but it is if our notion of education stays with you need to know all the answers, because now we have a machine that has all the answers. And it's just like, I'll just ask them all the answers. And we often in the program, that I've said before, don't use Google too much, like even to look for things, because every time you look something up, you're stealing your own learning a little bit, right? But there's some times where you just need to get stuff, somewhat quickly. You can't rediscover everything in the universe all over again. But anyway, so that's my answer. I'm only worried about AI once the emergent tech consciousness comes, and then I didn't think there was a path to that, but now I think the next ChatGPT is going to have like 1 trillion tunable parameters, ChatGPT 5. So if you look at the curve, there could be an order of magnitude more within 5 to 7 years, and 10 trillion is certainly enough complexity to potentially produce an emergent consciousness, something like ours. Not that neurons and tunable parameters are the same thing, but anyway. Thank you. Great question.
Yes, thanks.